This conference will now be recorded.
We will start with the session now. So first let us start with the course overview. Then we'll talk about agenda, the course schedule, agenda, and notes. So the course will be for, basically the course name is System Verilog for Functional Verification. This will be done over 13 weeks duration. We will have sessions on weekends and weekdays based on your availability. I mean, if you are only looking for weekend course, the training will be only on weekends. If you are looking for both weekdays and weekends, I mean, you're looking for full week course, the sessions will be planned accordingly. So today's session will be from, as you know, 10 a.m. to will go till around 1:30 p.m. For the next sessions, I will publish the schedule in the WhatsApp group to which you are added. That is the schedule actually I want to talk about. Now, regarding the course overview, the course is divided into 3 parts. 6 weeks of training on system Verilog language constructs. Everything, I mean everything in system Verilog, starting from basics of system Verilog language, like what is system Verilog, what are the data types, what are the literals, operators, then arrays, mailboxes, queues. Then we will go on to understand object-oriented programming. Then we'll further go on to understand program block, interface, mod port, clocking block, coverage. For that matter, everything: functional coverage, code coverage, assertions, constraints and randomization, DPI, array methods. Everything will be covered over 6 weeks duration. Then later part will be 2 weeks of around 2 to 2.5 weeks of training on 2.5 weeks of training on AXI protocol and AXI VIP development. Later, around 4.5 weeks, or you can say 5 weeks of training on one of the standard project, and a standard project, and a medium and a complex project. I will call it as complex design verification. Okay. During this 6 weeks training, also we'll be doing one mini project. So essentially, at the end of this 13 weeks of training, you will be able to add this project, and this project into your resume. And all these things will be doing from scratch. I will be doing everything, all the examples of system Verilog, all the examples of AXI verification, API development, design verification will be done from scratch. We are not going to show the existing code and show you this is how the component is developed, this is how test cases are developed. Rather, we will be doing everything from scratch. Now, coming to the course schedule, I have given you a course schedule. Typically, irrespective of in what domain, in what mode you want to do, whether you want to do only weekend mode or full week mode, all theory sessions will be supported by lab sessions. Now, if we are looking for full week course, lab sessions will happen over weekdays. Will be in weekdays. If you are only looking for weekend course, lab sessions will be on weekends. So please do not worry that I'm a weekend student. How will I back up? weekday sessions. So even if you miss any weekday sessions, you don't miss anything. You will still be able to attend the weekend sessions. I mean, you will have the labs being covered on the weekends. If the timing doesn't still work for you, let's say week labs are done from 1 p.m. to 5 p.m. for example, and those timings doesn't work for you, we will arrange a dedicated labs for you. That is mostly I'm talking about the students who are attending from US and Canada. Okay. This would be the course agenda and the intention of lab sessions. So now, what is the intention of theory sessions? What is the intention of lab sessions? Let us understand those things. I would rather say objective. Objective is trainer will teach all the essential things, essential topics with detailed examples, and trainer will do all the project development from scratch. This is the objective of these sessions. So students are not supposed to do any labs or projects during these session timings, except for few in session, in class assignments. I mean, during the class, I'll be asking some assignments and questions. Those things you are supposed to do. These theory sessions are not meant for student to do any practice. Lab session is where there will be a trainer providing the guidance. Objective. What is objective for this? Trainer providing the guidance to the student in completing the course assignments, labs, and projects. How it will happen is trainer will take a specific assignment. He will give you time. I mean, student will be given time to complete a specific question. If you are not able to complete, the trainer will do the question and trainer will implement that and show it to you how to do that. But mostly the emphasis is on student doing the things. Okay. So this is where you really get to learn a lot. And one more suggestion I have is do not wait for lab sessions only to do the practice. You can always do the things outside the lab sessions also. Student can always practice the assignments, labs outside session timings. So please keep yourself motivated. Do not just wait for trainer to come and tell that, have you done this assignment? Have you done this lab? Have you done the project? You can always practice outside the session timings. So sessions will only run more like 4 hours in a day in any case. Remaining time, you can practice yourself on the assignments, labs, and all these things. Now, where to find, what is the course material? I mean, where to find assignments, where to find labs, all those things. One complete consolidated link is this one, SV course overview. This is where you get all the details. Actually, I have written as 10 weeks. It is not 10 weeks. It will be 13 weeks. See, that is what initially when we started off the course, we felt that 10 weeks was sufficient. But later we felt that to cover so many topics in depth, the 10 weeks was not sufficient. So we have to make it 13 weeks course now. Now, you first of all, before you start with the course, what are the prerequisites? Student should be familiar with Verilog for design and verification purpose. You should know basics of Verilog and design. What is task? What is function? Basic how to work with, how to declare arrays, how to declare a vector, how to implement a simple module coding, test bench coding. What is the intention of test bench coding? Basic idea about what is meant by a test case, and other than that, familiarity with operators, at least basic operators like assignment operators, comparison operators, etc. I mean, at least this much basic familiarity is required. If you don't understand whatever I have written here, then better you have to start with Verilog training. Because do not come with the assumption that Verilog and System Verilog, two different topics, I can directly start with System Verilog. Without proper understanding of Verilog, you will find it difficult to cope with System Verilog. So please make sure that you are familiar with these things. If you still don't get the idea whether can I directly join System Verilog training, you can always go and take an assessment test here. Entrance test. You go to this link, entrance test. System Verilog entrance test is there. I mean, if you want System Verilog entrance test is for students who plan to take System Verilog training, directly skipping Verilog training. You go and take this test. There are only 9 or 10 questions in this. If you are able to score at least 70%, at least 7 out of this, whatever, 9, how many questions I have? 10 questions. Then you are good with Verilog. You can directly start with System Verilog. Okay, so prerequisites are what? Other than that, you should be having basic idea of how to work with working knowledge of GVM, working knowledge of model sim or Questa sim. Now, what if you don't know? You have never worked on GVM, either GVM, Notepad++, or you don't know what is model sim, how to use Questa sim. What to do in that case? If you go to this link, you can watch these videos. So go through this. In this, refer to 2.2. As the video links. You please go and watch these videos. How to use GVM. This will talk about what is GVM, how to split the GVM, and how to use different features of GVM. Everything it talks about. Other than that, you can practice how to use Questa sim, how to enable System Verilog syntax and GVM. See, whenever I type any System Verilog file, let's say SV labs, let's say array.sv. If I just take module top, you see automatically that brown color comes. So whatever are the System Verilog keywords, they come in brown color automatically. It is because I have done something in my GVM setting. See, whatever GVM I'm using, in that I'm using some setting updates, which is automatically enabling this coloring to happen. That you can get that knowledge, that information by going to this link. You follow the steps in this link, you'll get that. Other than that, now coming to the System Verilog assignments. System Verilog assignment 1 to 15. These are covering all the aspects of, I mean, I will update what are the topics covered in each of these assignment. You can go and check as well. If you go to this System Verilog assignment 1, it will talk about object-oriented programming in depth. So this is one of the longest assignments in the System Verilog course. Similarly, you can go to other assignments, and the final goal of this course should be, this course will have around 17 assignments, or 17 or 18 assignments. The course will have 18 assignments total for 13 weeks course. That means on average 1.5 assignment per week. If you can do that way you can complete all the assignments in 13 weeks duration. So that will require you to spend a considerable amount of time. But on a positive side, once a student completes all 18 assignments, okay, either by self or with trainer assistance, student will gain a good expertise, very good expertise on system Verilog, both from language perspective, both from a project execution perspective. That is, first thing is the course assignments. I think this should not be part of course material, it should be part of just assignments. Along with that, we will conduct evaluation tests towards end of the course. Based on that, certificate will be issued. You need to score some minimum percentage of marks, then we'll issue the course completion certificate. Now, coming to the course material, we have a proper complete set of course material that we'll be sharing with you. So the verification IP development, digital design document, Ethernet project code, interview questions, memory controller project, memory controller documents, how to use tool, Questasim tool, some SOC documents, basic how to create simple system Verilog examples, some system Verilog course documents, labs, and session labs, in whatever labs that have been done in the session. I mean, these are all the things that we have done in the session. All these things will be shared with you. Other than that, assignments and project update in the resume, how to update the topics in your resume. All this material will be shared with you. So the material will be shared from Google Drive. Other than that, session notes, whatever I'm writing, in fact, whatever I'm writing, it's a session 1 notes, right? Notes will also be shared. Okay. And the session labs also will be shared. These things. And finally, you can refer to this document, how to update project in the resume. You can accordingly update your resume as well. Now, coming to so this is about course overview. Now, do you have any questions regarding the course, regarding the timings or any content, any other queries? Okay. Now, regarding what is the expectation from student? At least spend minimum time every week. Make sure that you are able to complete the assignments as per the schedule. Complete assignments as per the schedule. That is the primary expectation. It doesn't matter whether you attend the session or not. You have to complete the course assignments. I mean, you will realize that to complete this assignments, of course, you have to attend the sessions. In case you miss a session, let's say some basic queries like what if you miss a session? We will share the recorded video of the session. Recorded video of the session will be shared. Okay. Any other questions you have? Next, let us start with the today's session. In today's session, we'll be understanding the system Verilog training objectives. I have already given an overview of what to expect from the course. We will first of all start with the system Verilog language fundamentals, basic data types, how to work with, I mean, before we start with complex aspects of system VLSI, what are things you should be familiar? Those things we'll start with, like how to declare arrays, how to declare dynamic arrays, queues, etc. Mailboxes, associative arrays. Because these things gets used at various stages of the course. So I felt it is good idea to introduce you people to basics of arrays, queues and mailboxes before we can start with the object oriented programming. See, once we are done with this, we will go with object oriented programming. That would be next week only, because today's complete session will be required to teach all these fundamentals. So I will start with the session. So the course name is System Verilog for Functional Verification. Functional verification overview. In yesterday's session, I have already talked about, in the demo session, I have already talked about functional verification overview, but I will quickly read through this. Okay, my assumption is that you already have gone through these topics in the yesterday's session. First of all, let us understand what is functional verification. Functional verification is process of validating design functionality against the design specification. That is, whether RTL or behavioral code, is it working as per the design specification. What does functional verification engineer does? Functional verification engineer responsibility is to catch functional issues. So the role of functional verification engineer is to catch the functional issues. That is what we call as design issues. The functional verification engineer has two inputs. One is design specification, one is the RTL code. So by reading the design specification, he understands how RTL should behave. So by reading, what is functional verification? Okay. Two inputs. One is design specification. One is RTL code. By reading design specification, the user understands, user means verification engineer, understands how design is supposed to behave. Different features it supports. See, understand how design is supposed to behave. Different features it supports. All those aspects. How many subblocks are there, everything. In summary, all those things comes down to this only. How the design is supposed to behave on different feature it supports. Now he sets up a verification engineer, sets up test bench for doing complete verification. Yesterday we have already talked about how test bench will look like, what are the different components of the test bench, all those things. Like test bench has two types of components. Components meant for scenario generation. And what is that? The generating inputs to the design. Let's say in my laptop, example is what? I'm checking keyboard in my laptop. So typing keyboard pads is the scenario there. Second is, what are these components which does this? BFM, generator, and functional configuration. Second is components that are meant for checking purpose. Component meant for checking purpose, checking the design behavior. So what is it? Design, as per my understanding, as per verification engineer understanding, he is expecting a specific output to come. And design is giving an output, is giving one output. Checking whether both of them are matching is what is the intention of these components. So what are the components meant for this? Components meant for this are monitors, reference model, register model, assertions, checker, and score. So two types of components will be there. So during yesterday's discussion, demo session discussion, we have understood that when I'm saying yesterday's session, we had a demo session yesterday in which we have taken an overview of what is functional verification. There we talked about what is module level verification. In that session, I have already given what is these types of components. If you want more information about that, you can go to this link. You can go to the demo session. This link, the first link, has the complete details. Somewhere around this is around 3 hours video. You can go through the 2 hour onwards. You will find this corresponding discussion. Then, so functional verification engineer role is to what? Catch the functional issues. He gets two inputs: design specification and RTL code. Verification engineer develops test bench to make the functional verification more process oriented. There are two types of functional issues: bugs due to wrong understanding of wrong coding mistakes. Okay. Now we have already talked about why functional verification is important. Functional verification is important because functional verification is the only stage where you will be able to catch the design bugs. If there is any coding bugs, if you don't detect in functional verification, they will finally come into the chip and your chip will not function properly. So then we discussed that functional verification driving factors are two things. Less time in setting up test bench, more time in developing test case and debugging those. That is why we are moving from Verilog to system Verilog to UVM. Then we talked about different types of verification: SOC verification, subsystem verification, and modular verification. We also discussed about what is the that you target during SOC verification, what is that we target in subsystem verification, what is that we target in module verification. In any case, specification is input to both designer and verification engineer. Verification engineer should try to gain expertise in all the domains of verification in 5-year horizon. Given a 5 to 6 years experience, you should try to gain expertise in all the domains. And the following slides will talk about various types of functional verification. We have already talked about in the yesterday demo session. We have talked about different types of functional verification, like different steps in functional verification. Starting from reading design specification till the time we do functional verification closure, we go through all these steps. Then we took one reference design like universal memory controller, understood what all steps we follow through that example. Then we discussed that this is how we come up with the test bench architecture. This is the DUT that we are verifying: design under test. To verify this design, we have to set up all these things. In fact, all these things are done by the verification engineer. This is coded by the design engineer. In this diagram, it is the only DUT which is developed by design engineer. The rest all components are developed by verification engineer. BFM is developed by verification engineer, scenario generator, function coverage, everything you see in this one, all these are developed by verification engineer. So hence, a verification engineer requires as much understanding of a design engineer. Let's say design engineer has understanding of the design. Verification engineer also need to have same understanding of the design so that he can efficiently verify whether DUT is working properly or not. Then we talked about test bench requirements, different components that are required in test bench development. Then we talked about what is modular. I mean, why do we code test bench in so many components? It is to maintain modularity and reusability. Then we took example of okay, we haven't did this basically. Yeah. I will come back to this traffic light control example in some time because I don't want to start with actual verification. I want to make sure that you are familiar with the basic data types. So I will directly start off with system Verilog data types. Once it is done, then we'll take overview of functional verification. What is functional verification? Using traffic light controller example. So I will, right now I'm skipping these topics. So for this, what is my expectation here is, I will just keep it here. Basic data types, a task, functions, etc. These things. There are few things I'm going to teach which might be very basic to some of you, but I want to make sure that I still start from the fundamentals. Okay. Now, first question. I want everyone to try here. Question 1. Declare an integer, declare 2 integers. Write a logic in module. Use mod in module. Declare 2 integers and write a logic to generate random values to them, to assign random values to these integers and compare these values. Compare these 2 integers. Can you please try this once, everyone? Random values between 50 to 100. I want to assign random values between 50 to 100 to these integers and compare these 2 integers. So how do we do that? So let's compare int. I'll just say int.sp. Module top in module integer a, b. Initial, begin, end. A equal to, in system Verilog, there is something called as $u random ranges. What is it does is, u means unsigned, means positive only. Random means random number. Range means within a range, within user specified range. So you're telling that generate a random number between 50 to 100 and assign it to A. And B equal to $u random range 50 to 100. Then what you do is, you do if A equal to B, begin end. Okay. Display, $display. Both A and B are matching. Else, begin end. Both A and B are mismatching. To run this example, I'll be setting up one run.do file. Vlog int.sv. We are developing a int file, int.sv. We are compiling that file. vsim -no vopt. No vopt means we are telling do not optimize the that executable file. I mean the output. What is that? If you are using top module here, you have to use work.top. Then run -all. The benefit of this run.do file is I can just go here. You go to that folder. Do run.do. That's all. You just need to do run.do. It will run all the steps one by one. Instead of you doing compilation, you doing elaboration, simulation step by step, you can do this way. See what is the output coming? Both A and B are mismatching. Now you can just generate the values of A and B when they are mismatching. I want to see what is the value of A. A equal to percentage D, B equal to percentage D. You write A comma B. If you want to write time, at what time it happened, percentage T, you write $time. Please do not, I mean, you may be wondering why are we doing integer comparison after all this? I have already learned this in very long. There could be few students in this session who may not be so much familiar with these concepts also. I want to make sure that we start from the little bit of basics only. Okay, now if I run this, to run this, I again have to just say do run.do. Oh, my tool has crashed. See, both A and B are mismatching. A equal to 59, B equal to 87. Now, how do I get rid of these spaces? Can someone suggest me how to get rid of these spaces? Even see here, it is giving this much space. How to get rid of this? I have to write percentage 0t, percentage 0t, percentage 0t. That will make sure that when the print happens, it will print to the leftmost location. If there is nothing to print, it will ignore those position, those spaces. Now if you run, it will give us. Now it gives like this. Is this the only way to compare? In system Verla, the question is this the only way to do the comparison? Can I do comparison in some other way? Yes, there are other ways to compare. What is the other way? Is using assert. Compare using assert. Assert, just write A equal to B. That's all. Okay. You write this message, $display. Compare is passing. You write else. You write $error. Then you don't need to write error. Just miss. I'm running both of them just to show you how it comes. See, this message is coming from here, this one. The second message is coming from the assert. See, assert error 0. Both A and B are mismatching. A is 59, B is 87. So at time 0 equal to nanosecond and line number 15 it is failing. So which is more informative? Can someone tell me? Is the first message more informative or is the second message more informative?
using dollar error.
No, basically using assert is more informative. Using assert is more informative. It gives you which file, which line number also mismatched. Here it doesn't tell you. It only tells you that at time 0, some failure happened, some error happened. But second one gives you that it is an error message also. Why this error is coming? Because I used $error. Because I used $error, it prints it as error. If I had used warning, it would have printed warning for me. It is printing a warning. And it tells you from which line, what is the scope, top module scope, which file in .s, which line number. Hence, if you have any option, always use assert instead of if condition. If doesn't tell you the line number, if it doesn't give you additional information. Is it clear to you till this point?
Excuse me, sir. Is assert statement a conditional statement or like just an informative?
Assert is a conditional statement. If I write assert 1, it is true. What it does is, what is assert is, assert checks, let's say, expression. If expression output is true, logically true, then assertion passes. If assertion expression is logically false, logically evaluates to true, I will say evaluates to true. If expression logically evaluates to false, I would say logical false, logical assertion evaluates to, expression evaluates to, assertion then fails. It will execute else case. What is else part of the code? Else part. What is else part in this case? You could have written $display also, but assertion have this flexibility where you can report $error, $fatal also. See, for example, if I run $fatal, and if I write some other message, let's say I move this checks later, 6 down to 11, D5. Here I will move. Okay. Now you see what happens. Tell me, what do you think? What should happen now? Tell me when I write $fatal. See, they are mismatching. Because of fatal, what will happen? Can someone tell me?
Simulation
exit immediately. So when it comes across fatal message, if fatal happens, simulation exits at that point. It does not proceed further. So in this case, these statements doesn't happen if you run fatal. Are you getting the point? What is the flexibility by using this $error, $fatal, all those things? Can you please understand this code? Okay, so I hope you have understood. Do you have any questions here? Okay, next. Int integer. Int integer dot is. Basically, what is difference between int comma integer? So for that, what I will do, I don't need all this. Idea is just to understand difference between int and integer. Int c command d. Basically, int is a two-state variable. Integer is a four-state variable. Means what is four-state means? 0, 1, x, comma, z. It can only store 0 and 1s only. It cannot store x and z. If we assign x or z values, they will be stored as zeros only. So let us see a equal to 32t h 1x 0 z 10 zx, something like this. C equal to same thing every day. Let's dollar display a equal to percentage h, b equal to percentage h. Sorry, c, right? You have to write a comma c. And to run this example, go to run.do. You make it int integer. And what is the topmost module name? Top. I have to give work.top. No vopt means as of now there is no significance of no vopt. Even if you run without no vopt, output will still be same. When we have to see the waveforms, when we have to do the logging, that's where no vopt is important. All you have to do is what? Yeah, stop the simulation. Do run.do. So now a different example is being compiled, not the previous example. We are running a different example now. See, A is holding x and z. Whatever x and z you have given, it is holding. Whereas C is converting them to zeros and zeros. See what it does is, it is converting x to 0, z to 0, x to 0, z to 0. Because C is a two-state variable. Even if you assign 0, x and z, it will convert them to zeros. That means, what does it mean is, if A equal to 32 h 1x 0z 10xz. If I write assert, I will get a passing message. If I write C, you'll get a failing message. You just have to write assert. That's all. No, don't do anything. Also, it will run. You see now. That's the beauty of assert. What assert does is, assert doesn't care what it is doing. It will check whether this evaluates to true or whether it evaluates to false. Tell me, what does this evaluate to? Line number 9, a equal to what does it evaluate to? Can someone tell me? Can someone tell me what does the first one will evaluate to? True or false?
True.
It will evaluate to true, right? True, right? Because a is same as this one only. So then my assert should pass. Okay, can you see this now once? Assertion error. Okay, reason is wait, equal to right. Let's do triple equal to, because it will do the case comparison, right? Double equal to is only what? If there is a x, it will evaluate to x only, right? See, first one has passed, hence you are not getting any message. For this line number 9, you are not getting any message. For line number 10, you are getting a message, assertion is failing. Error, assertion error is coming. Where? Top scope. File is int integer.sv, line number 10. So that is how you use assertions. For example, if I write assert 10 equal to 10, tell me, should it pass or what message should it give? It should give a passing message. Whereas if I write assertion 9 equal to 10, you'll get this kind of message. Assertion error, line number 12, int integer has failed, like that you'll get. Is it clear to you what is assert, what is int, and what is integer? Do you have any questions till this point? How to declare arrays. Okay, now let us understand how to declare various types of arrays. Fixed size array dot s module top n module. So here the requirement is, my requirement is declare array of 5 integers, array of 10 integers, and one more array of 10 integers. Assign random values to both the integers, both arrays, both the array elements, and compare one array against another. Can you please read this once, requirement once? Okay, so let us try this once. Because I'm declaring array of 10 integers, I'm calling it as fixed size array. So how to declare fixed size array? Int array int a1. Okay, fixed size array fa1. Okay, 9 down to 0. In system Verilog, it is also possible to declare it as 10. It will automatically treat it as 9 down to 0. In Verilog, not possible. Verilog, it is not possible. It is not supported. In Verilog, you must write 9 down to 0. In system Verilog, you could have written int fa of 10 also, or 9 down to 0 also. I will declare one more array with 10, just to show you that both the things are possible. So fa means what? Fixed size array 1, fixed size array 2. Now, what is my requirement? Assign random values, let's say between 20 to 30. I'm assigning random values between 20 to 30, 20 to 40. Okay. How do you do that? You always have to write this kind of codes in initial beginning, because you cannot write procedural statements outside initial block, right? Initial always block. How to do that? For int I equal to 0, I less than 10, I plus plus. See, these are few things that are supported in system Verilog. I can declare int inline. Here itself I can declare int, whereas in Verilog I have to write int I here. I can do like I++, which is not supported in Verilog. What do I need to do? Int FA of I equal to $u random range 20, 40. Same way FA2 also, because both the arrays I want to assign between 20 to 40. Now, how to print them? Now, first thing is print all those, print the array values. There are two ways to print. One way is simple packet printing. What is packet printing? Is $display int FA1 is equal to %p int FA1. Simple. FA2 equal to FA2. To run this, all we have to do is just go and change this to fixed size array. Do run. See, these are the values. First array has 3, 4, 5, 6, 7, 8, 9, 10. Second array has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 elements. Okay. But those values are not matching. You see, only except for here, nowhere else they're matching. Okay. Now, what is the other way of printing? See, one is packed print. One is printing on index basis. How do you print on index basis? You have to write a for loop again. Same thing, whatever you did here. And you have to write $display. Then you have to write I equal to index equal to %0DE. Int FA, rather I think it is better to write like this. Int FA of 1 %0D equal to %0D. Here you write what? I comma int FA1 of I. Then you can write one more for loop int FA2 int FA2. That is another way. You run this now. In other case, what will happen is 10 lines will be printed for this. 10 lines will be printed for this. 0 to 9, which is first array. This is 0 to 9 first array. See, 39 is the lowest index, 27 is the highest index. So 39 to 27. Sorry. It is wait. FA2 is 27 is the highest lowest index. It is, how come it is coming like this? See, it is printing 39 as the highest index, whereas for the second one it is printing 22 as the lowest index. So I will check and revert on this. It is conflicting. In one case 22 it is taking as the highest index, 9. In one case 27 it is taking as the lowest index. I need to check on this. I mean, this is some kind of conflict in the language itself, the way it is printing. I mean, some kind of conflict in the tool. Ideally speaking, this should have been the lowest index. This should have been the highest index. So there are different ways to print the values. Other than that, what else we need to learn? Okay, what is the next requirement for us? Compare one array against another array. The other benefit of this is, going back to this print and this one, the benefit is, if you want hexadecimal, you can print in hexadecimal. That is not possible with %p. The %p always prints decimal values only. It doesn't matter what is your intention. Your intention was it to be hexadecimal, binary, it doesn't matter. It always converts it to equivalent decimal value, prints it either signed value or unsigned value, but it prints as a decimal only everything. See, if I run this now, because you are given hexadecimal, these values will be printed in hexadecimal, second prints. Mm, 39, 37, percentage 0h, int, is there something 32, 22. Did I not do this? I have saved it. Wait. Yeah, it is printing hexadecimal. It is printing in hexadecimal format. Whatever you take example of FA1B. 1B is what? 16 plus 11, 27. That is 27. What is 37? It is 25. 32 plus 5 is 37. So it is converting this into hexadecimal and printing them. So this kind of flexibility you won't get with percentage P. See, percentage P benefit is what? Packed printing benefit is it prints all elements in one line. Drawback is it always prints in decimal format only. So you have to decide what is that you want. Let's say your intention is to print in decimal, so packed printing is the best option. Let's say if you want to print in hexadecimal printing, then you have to go for individual line printing only. Individual line printing means something like this. So that is about these things. The next, comparing the array values. What is my next requirement? Compare one array against another array. Compare one array to another. How do you do that? Is it possible to write like this? If int fa1 equal to int fa2, or can I just write assert? Is it possible? Can someone tell me? Is it possible to do like this? Would it be correct to do like this? Assertion error will come. Line number 20. See, assertion error is coming on line number 20. This will fail. Why this will fail? Let us understand. Because when I do this kind of when I do array to array comparison by full array name, by using full array name, it compares their pointer values, not the array elements. What does it mean is, in my laptop where I'm running my this QuestaSim tool, there is a memory. In that memory, somewhere int fa1 is stored, 10 integers. Somewhere int fa2 is stored. This is the fa2 pointer. This is fa1 pointer. These values, this location is compared with this location. When I do this thing, when I'm doing this, this memory location is compared with this memory location. Do you think will it ever match? Do you think those two locations will ever match? No, right? They won't match, because two integer arrays will always be stored in two different locations. See, two integer arrays will always be stored in two different memory locations. Hence, array to array comparison will never pass. Okay. Let us do one thing just to prove that this indeed works. I will just do int FA1 equal to int FA2 and let us do the comparison. What happens? Let's see. We are assigning FA1 elements to FA2. Line number 20. FA1. Okay. This is passing. So it is the way I am looking at it is wait. Let's do one thing. It could be one mistake in my explanation. I'm sorry. If I am doing FA1 equal to FA2, it is probably comparing them only. I'll do one thing. Instead of doing this, I will do a for loop. I'll do a for loop and assign the elements of FA1 to FA2. FA2 of 5. So I'm assigning elements of FA1 to FA2. So now I want to see what will happen. Now assertion error is coming. Even though you copied both the elements, so you copied both the elements from one to other, they are mismatching. Why they are mismatching? Because it is not doing the value array value comparison. It is doing array pointer comparison. Next, I will do again one more thing. Do array to array handle copy. Array to array handle copy. Array completely copy int FA1 to int FA2. Now you do the comparison. So you're copying int FA2 handle to int FA1. So both at the end of this copy, both will point to same location. Both will point to same location because both of them we are assigning same handle. Now if you do, should it pass? Should it pass or should it fail? Can you tell me? Can you tell me this operation? Now what you are doing is both of them are you are pointing to same location. This location only. Array 1 also same location, array 2 also same location. Now tell me what should happen. Should this pass or should this fail? Can someone tell me? Hey Arun, regarding your question, is this part of DFT training sessions? It is a system Verilog training. DFT training will start from tomorrow onwards with Verilog training sessions. So please send us a mail. We'll send you the detailed schedule regarding that. So whatever we are doing is part of system Verilog. So it is not much related to DFT sessions. Okay. Coming back to this question, line number 28. This should basically pass. So to run this, all you have to do is just go and say. I hope you are able to get the benefit of what is assert, right? So you don't have to write a very long lines, 3-4 lines. You don't have to write. All you have to do is whatever you want to check, you just put between assert. In the brackets, you put whatever you want. Now this will pass. This should pass. See, only two assertion errors are coming. One is line number 20, one is line number 25. Line number 20 is this one, line number 25 is this one. Okay. Now, how to do the field level comparison? Array value comparison. Why are we covering these topics is sometimes by mistake you may end up writing like this. See, you may end up writing this thing, int fa1 equal to int fa2, which is wrong. We should not do that. We should do the individual field level comparison. You say if array1 equal to means, then you write $display array compare matching. Else, okay, you say array to array compare passing matching. Here you say array to array compare mismatching. Then you run this. So again, why am I writing if condition is to show you that writing assert and writing if condition, both of them are same. It is just that if requires more lines. See, if requires how many lines? 5 lines. The same thing assert will do in 1 line. See, array to array comparison is matching. Yeah. See, this was expected to match, right? Whatever line number 28, that was expected to match. So array to array compare is matching. Now, how to do array value comparison? So what I will do is, first of all, like this. What you do? You do if, rather you can do assert. That should be sufficient. You're asserting both of them. This is how you do array value comparison. Same thing you could have written as if condition also. Then you should have written begin and whatever statement you want to display. Now you run this. See, assertion errors are happening because it looks like both the arrays are having different values. Both the arrays are having different values. When you did this, both the arrays have different values. Hence, this assertion is failing. You see, it is giving errors on line number 38, 38, 38, all the lines 38. Now, what you do is you do this kind of copy. What is my next requirement is copy one array elements to another array, then do the compare. If I do this, how to do that? How do I copy? Using this for loop. Then how do I compare? This thing, 37 to 41, y4. Just come here, remove these two things. Tell me, should this pass or fail? Can someone tell me, should it pass or fail? Can someone tell me, should it pass or fail?
It should pass, sir.
It should pass. So for this, just go and run.do. Okay. Okay, if you again look at what I'm doing, I'm trying to make you comfortable with basic integer operations, array operations, how to do the value assignment, how to do the comparison, those things. These are the fundamental things you need to know before you get into the advanced aspects of system Verilog. That is the reason we are spending this time going through the basic operations. You see, this error is not coming. 48 assertion error is not coming here. Is it clear to you? So the next question comes is, int fa1 equal to int fa2. Is it same as this one? Are both same? Can you tell me? Can someone tell me whether both of them are same?
They are different, sir.
They are different. How they are different? How they are different? This is
The second one. Okay.
copying the handle value. Copying the handle. That is the memory location of int FA2 to int FA1. FA1 memory handle. Second one is the value copying. See, value copying. After this copy, both of them are in different locations. Both are in different locations. Hence, that's how they're different. So this is about arrays. Let me just go back to my labs because there I have it organized properly. Okay. Now let us talk about arrays with negative indexes. Arrays with negative indexes. So I will take one more example. Fixed size array, neg index. Just to show you that it is possible. -9 down to 0. Is it possible? So what will be the indexes in this case? Can someone tell me? -9. What all will be the indexes?
-8, -7 till
So till 0. How many elements are there totally?
Ten.
10 elements. So if I have to compare this, I just go here. You write neg index. Just to run down. So it is running neg index. You can see here. See, now 48 is failing. Okay, it will fail. Why it will fail? Tell me. It will fail because indexes don't match, right? You have to use different indexes. Because array 1 indexes are from -9 to 0. Array F2 indexes are from 9 down to 0. So the indexes start from 9, 8, 7 till 0. In that case, let's say, how do I do the comparison and how do I do the assignment? How do I do the changes? What changes should I do? First thing I have to change is this. I have to change. This should become -i. Correct, right? It should become -i. Then you make it -i. Then you have to write -i wherever F8, no, not F8, minus. For FA1 we have to use minus. FA1, and here I have to use minus. Somewhere down also I have to use -i, -i, so on. Now I run it. So we are trying to understand how to deal with arrays that have got negative numbers, negative indexes. See, output is coming as the same as the previous one. I mean, earlier whatever we had with positive indexes, same output is coming. So you need to learn how to deal with the negative index also. If you want to compare them, you have to make negative equal to positive. So again, it depends upon how let's say if I run index from -9 to 0, then I don't need to write -i, because anyway you're giving from -9 to 0. But then this won't work. This will take -9, -8, which is, but FA2 is based on positive indexes. To make it work, I'm using -i here. Here I'm using +i. So this is arrays with negative indexes. Next, working with dynamic arrays. System Verilog has a concept called as dynamic arrays. What is dynamic arrays means? Arrays whose memory can be allocated at the runtime. I mean, we don't need to define the array size at the time of array definition, array declaration. At the time of array declaration, you don't need to define the size. See, module top, end module, int da, dynamic array, like that's all. This is sufficient. If you declare some array like this, open and close brackets, open and closed square brackets with no number between, it is called as dynamic array. And let us say I have one fixed array, int fixed array of 10 elements. Initial, begin, end. Now, first of all, what do you do? What do you do is do these questions. Assign, allocate dynamic array with size of 10. Assign random values between 40 to 50. Print all those values. Using one using percentage %p, one using percentage %d. What you do is initial, begin, end. First, you have to allocate a memory. Int da equal to new. Int da equal to new of 10. Understand the concept here. We are allocating a dynamic array with 10 elements. But understand, we are not assigning all the 10 elements. We are only allocating the space. We are only allocating the space, not assigning values to them. Those 10 locations. Okay. Now, if I run this, for example, if I do $display int dynamic array equal to %p, if I do, and just do in dynamic array. To run this, what I have to do? Can someone tell me which line I have to change to run this dynamic array example?
First line.
First line. I have to go and say dynamic array.sv. Just go and do run that. There is a problem, failed to open dynamic array.sv. Dynamic array.sv. Oh yeah, actually I have coded it in current folder. I have to code it in SV labs dynamic array. Okay. See, all the elements are 0. What it is doing is, when I allocate dynamic array with 10 elements, it is allocating dynamic array to hold 10 elements, but it is not assigning values to those 10 elements. Now, to assign 10 values to 10 elements, what you have to do? You have to follow the same concept for There are two ways to do it. You see, for each is one way. You have to write int da of I begin end, int da of I equal to $u random range of 40 to 50. This is one way. Now you may ask, what is for each? For each automatically figures out the size of the array, that it is 10, and runs the index from lower value to highest index, that is from 0 to 9. It will automatically do that. So it will run this for loop for each, like running for loop from 0 to 9. We are assigning a random value from 40 to 50. Now you go and run this, you go and display it. We didn't save it, looks like. You have saved it. Why is it not printing? Dynamic. Oh, sorry. Again, I will close it. I'm saving it in my. Let me close it. Let me open. B7. See, now it is taking random values between 40 to 50. Do you understand the difference between, first of all, do you understand what is dynamic array? What is dynamic array is? Now let me explain you. Dynamic array is, we can change the size of the array at the runtime. What is meant by that is, now you can go and say int da equal to new of 20. In the bracket you do int da, you do print int da. Now you run it. What is the new size of dynamic array? Can someone tell me?
20.
Because we wrote this line, because we wrote this, what we are telling is, this is making two things to happen. Print the values. Okay. Next requirement is increase the size of the dynamic array to 20 while keeping the initial 10 elements intact. Intact means what? They should not get recreated. We should just keep them intact. So this, what this does is, 20 is making sure that increase the size to 20. Int da is making sure that whatever existing elements of int da are used. So that is the reason you see existing elements are there. Whatever was there here, it will be there. We are increasing the size to another 10 elements. If I don't do this line, we can change the size of array and completely create new, completely erase all the elements, reinitialize all the elements. All you have to do is just remove this. That's it. Everything freshly gets created. Oh, sorry. What happened is you have erased it, right? So you have erased it. If you use it also, you will get erased values. So rather, I will do one thing. I will assign it to int da1. Let me just do one small change and keep it here. I will assign it to one more dynamic array called as da1. So let me declare one more dynamic array called as da1. So da1 I am assigning. So you call it as da1. Call it as da1. Okay, you see da1 is holding the 10 elements and last 10 elements are 0. In int da all elements are 0 because we are doing new on complete array without putting in brackets what you want to copy. That means it is possible to copy one dynamic array elements to another dynamic array. There is a difference between, see, this line is different from okay, and int da equal to int da. Are both above lines same? Can someone tell me, are both above lines same?
No.
No. How they are different?
First line, it will print 10 element of entity and 10 new elements. In second line, it will just print the same thing.
It's not the printing that is the question here. It's both are different because this is the handle copy. I mean, copying int da memory handle to int da1. That means both are after this copy, after this line, both will point to same memory location. Here we are creating a new location for int da1, just copying the values of int da to int da1. Do you understand the difference? See, in one case, this is the memory. In one case, in the first case, let's take the first case. What we are doing here, da is there already, 10 elements are there. What we are doing is we are creating int da1, 20 locations. We are copying 1 to 1 copy, that's all. And whatever elements I don't have, I am assigning 0 there. This is first line. In the second line, what I am doing is, I am just I am not creating this. In the second one, I am just pointing this to this location. Both da1 and da are pointing to the same location. Do you agree that both of them are same or both of them are different? Can someone tell me whether both these lines are same or different? Whether these both lines are same or both these lines are different? I want session to be responsive. I mean, where you have to talk. There are 19 participants in this session. Even if one person doesn't talk, I don't know whether you are following or not. You have to say yes or no. If you say no also, no problem. If you say yes also, no problem, right? I will, at least I know what is happening with you. Are you following or not? Whether these two lines are same or not. Again, same 19 people. I don't know whether you understand English or you don't understand also. Whether these two lines are same.
No.
Sir.
Thank you very much. Okay, they are different. I have given the explanation why they are different. Please try to keep the session more interactive. That's where I feel more energy to cover different things. Next. dynamic array. Okay, new size what we want. Next, what we are going to do is declare in dynamic array example, declare fixed size array, or declare one more dynamic array, another dynamic array, copy elements from one dynamic array to another. Okay, that is what we are going to do. So here what we will do is, we have dynamic array 1. Now what I want to do is copy you again, just allocate freshly again. Copy all 10 elements from int DA to int DA1 while reducing the size of int DA1 to 10. I want, see, till here it was 20, right? You have assigned 20. I am assigning 10 elements. See, you make it 10 elements. Int DA equal to 10, new of 10. You are resizing array to 10 elements. And then you are running a for each loop where you are copying the values. You are assigning random values from 40 to 50. Now I want to copy all 10 elements from DA to DA1. How can I do? Do I need to write a for loop, or is there any easy way of doing it? Copying 10 elements from int DA to int DA1. Is there any easy way of doing it instead of using a for loop?
Yes, I use the new and give the.
So we have to do this. Then that's all. Now I can do the comparison. How do I do the comparison? Int DA1 of. So I have to write a for loop first of all. Okay, right now what you do is you just do assert int DA equal to int DA1. Should it pass or should it fail? Can you tell me? For at line number 30, should it pass or should it fail? Assert should pass or assert should fail? Assert should fail because both of them are pointing to different memory locations. Assert is not failing. Wait, DA. I'm running dynamic array only. Line number 30. Let me check and revert back on this one. Why this is passing? Ideally, it's passing. If no message comes means no message comes here means assertion error message comes means this is actually passing. I'll check and revert back because here the assumption was that both of them should be comparing handle to handle. It looks like they're comparing values. So now I'll run for loop where I will do the comparison. So you can write for int I equal to 0, I less than 10, I plus plus begin end. What you do is assert int DA of I equal to int DA1 of, just doing one index to other index comparison with elements. See, those assertion is also passing. So here, I mean, probably our understanding is wrong here. So when I'm doing it, probably handle elements, maybe otherwise way we have to understand is in case of dynamic arrays, elements probably get copied, elements gets compared. So So in summary, what I want to say is, when you want to do the array comparison, right? Never use array to array compare. Direct array to array compare, don't do. Always do the specific element to element compare only you do. That is the suggested way. So when we want to compare the arrays, whenever to compare array elements, always do position by position compare, element compare, like this. One index to other specific index, only you do the compare. You can just to check that it indeed works differently. I mean, it will fail. What you do, you take for different array, you assign another for DA1, you write different range of values. Then again you write this for loop. Now those assertions are failing. Line number 39. That will be in line number 39. Now reduce both the array sizes to 5, then compare. How to do that? While retaining the values. While retaining the values. How to do that? Int DA equal to new of 5. Int DA of 1. Int DA equal to new of 5. Int DA of 1 equal to new of 5. Int DA1. Do the same thing now. Right. Do this. Now they should pass. They will fail because they both hold different values. See, they are also failing. 5 failures because 5 comparisons you did. What if I do this? Will they match? 42 to 47 y5. Paste it. Will it match? Can someone tell me, will this pass now?
Pass.
Okay, so you do now comparison, they will pass. Why they will pass? Because int DA also will hold same values, int DA1 also will hold the same values as int DA. See, that mismatch is not coming. This line number 53, those mismatches are not coming here. Is it clear to you? This is why we call it as dynamic array. You understand why it is being called as dynamic array? It is called dynamic array because at the runtime, we can change the size of array. We can increase the size of array. So for dynamic arrays, it is possible to allocate array elements at the runtime, increase the size, decrease the size, completely erase the, remove all the elements also, and make the size equal to 0. You can make the size also 0. How do I make array size equal to 0? Can someone tell me? So make int DA size equal to 0. How do I do that? Can someone tell me?
Empty brackets.
int dA equal to new of 0. So dA size will become 0. How to get the size of array? Let's say how to get the size of array. Let's say if I did this, okay, resizing to 5. Int dA equal to dA1 we are copying. Let's say how to get the size of array? Size equal to int dA dot none dollar display size equal to percentage d size. You may ask, do I need to use size only? Can I use something else? Yes, you can use xyz here. You can use xyz here. So since I'm using size, I have to declare int size. Okay, size is field num not in line number 61. It is not num. We have to use size. The method is size. Size equal to 5. So the best thing about system Verilog is, good thing about system Verilog is basically best part of system Verilog is system Verilog implements various language constructs like array, dynamic arrays, mailbox, queues, associative arrays, semaphore, different things, and all these constructs methods are automatically implemented. User just need to know how to use these methods. User just need to know how to use these methods. User doesn't need to worry about how these are implemented, how these methods are implemented. All those things user don't need to know. User need to know what are the methods. Just know what are the methods and need to know what are the methods, what are these methods, and how to use these methods. That's all. Right? So now to understand this, let us go to the next topic, queue. System Verilog has a new type of data type called as queue. So I'll just system queue.s. Module top and module. Now, first of all, how to declare a queue? Queue is declared as int queue of dollar. So when you write, so int is the data type of the queue, dollar is the indicates that it is queue. So what is it basically? It's a queue of int data type. What is it basically? It's a queue of int data type. So you can come here. Now what you do? Int queue of dollar. So int queue of dollar. See, please note, int queue is not making it queue. Is not making it queue. It is dollar is what makes it a queue. That means to say, if I write xyz, xyz is still a queue because you wrote dollar in the brackets. Next, how to assign values to Q. So basically working with Q example. First of all, declare Q, assign random values to Q between 10 to 20 to Q, 5 random values. Print Q elements. And learn how to use different Q methods. First, let us understand how to declare a Q. We have already understood how to declare a Q. Next, we'll go to the second one. This one. Assign 5 random values between 10 to 20. How do I do that? For loop int I equal to 0, I less than 5, I plus plus. Beginning. What you have to do is int Q dot push back dollar U random range of 10, 20. Are you finding this statement complex? Does anyone want me to explain this statement? Whatever I wrote in the line number 6.
Yes, sir.
See, what we are doing is I have a int Q push back into the Q. I'm pushing back. So this is like a Q. What is the time pushing back? A random number between 10 to 20. I'm pushing back. When I push again, whatever is there, it will go here. When I push again, whatever is there, it will go here. It will come. New value will come. So as you start pushing, the first whatever you pushed, it will come to the beginning. Next, what you pushed will come to the next, so on. So what you pushed first will go to the beginning of the queue. Is it clear to you? Please understand this again.
Yes, sir. Clear.
To print the values, Q values. Now, how to print the values? Same concept, dollar display int Q equal to percentage P int Q. Just to make sure that you understand the what order they are being pushed, instead of this I will push I into it. Same index I will push. So that means what? 0, 1, 2, 3, 4 should come. My order of printing should be 0, 1, 2, 3, 4. So to run this example, I'll make it Q. So to run this, do run it. Zero, 1, 2, 3, 4. This is the 0th index value, first index value, second index value, third and fourth index value. Is it clear to you? Does anyone has question so far?
So just one question, like the pushback is like a function, or like usually in Verilog we don't use any like we use only
No,
dollar
that's what
sign.
I told, right? I told you this statement. Can you read this again? Have you read that?
Yes, sir. Yeah.
Did you understood what I meant by that? So queue comes with methods. Queue methods are push back, push front, pop back, pop front, shuffle, sort, or sort, insert, delete, size. It comes with so many methods. So this is the best thing about system. What is the best thing? It comes with, it tells you what is a queue, and it also tells you these are the methods you have to use. These are the methods that are implemented in queue. You just need to know what is pushback. What is pushback? As the name suggests, push the elements to the end of the queue. Push front, tell me what should it do? Can someone tell me?
Pushing the value from front.
To the front of the queue. So let us just try that once. You go here, you take this example between not 5 values matching index. 4 to 9, why 5? Instead of push back, you say push front. Now, can you tell me int q will be printed with how many elements due to this operation? Can someone tell me how many elements will be there in int q after this, all these operations?
10.
10 elements will be there because you did not erase it. On top of that, you are adding new elements. So totally 5 plus 5 it will become. If you see 43210 is what you pushed in the front. Because of that, it's coming like this. These are the pushbacks. These are the push fronts. So what if I wanted to erase in between? What if I wanted to erase? So to erase it, all you have to do is int q. Let's see. I think this one. Okay, let me try. There are different ways. I will try both the ways. See, now it is, you are deleting it. You are erasing all the elements. There is other way is delete. Instead of doing this, you could also do delete. It deletes all the elements of queue. It makes it empty. This delete will make it empty. So only thing you need to know is what is delete method and how to use delete method. You don't need to know how delete is implemented in the system Verilog simulator and language. Is it clear to you? That is about pushback and push front. Now what is pop front? Into this array, if I do pop front, what will happen? Pop the pop front. So what do you do? Y3, just come and say pop front. How do I print those values? Very simple. You do $display directly here. What order should it come? 43210 should come, or 01234 should come when I do pop front. Can you tell me when I do pop front from here, 43210 order should come or 01234?
0, 1, 2.
432.
Okay, so this I is not important. That's a mistake. No, 43210 should come because 4 is in the front of the queue. 4 is the front of the queue. So whatever is the front element, it will come first. then 3 will become the friend. 3 will come. So you see 43210. After that, after popping, let me print the Q again if it has any elements. So after popping all the elements, print Q, print again. Q is empty. Since you have popped, everything has been removed, so it is empty now. Okay, that is about pop front, pop back. What is shuffle? Let's understand. To understand shuffle, let's just assign random values, or you can do the same thing. Y equal to 3. Int. Let's declare one more Q. Copying one Q to another Q. Let's try both of them. Q1. We are copying Q1. Let's do int Q equal to int Q1. Let's print int Q. After this copy, let's see what is that will be there in int Q. So copying after copying from int Q1. It has got 0, 1, 2, 3, 4. See, after copying, once you did copy, all the elements gets copied from one Q to other Q. So it is possible to copy. So copying all the elements of int Q1 to int Q. Now you do shuffle. See, simple. Int Q dot shuffle. Tell me what shuffle should do. Can someone tell me what shuffle should do? Can someone tell me what int Q shuffle should do?
It will change the value which is in index.
Yeah, basically
Shuffle.
it will arrange them in the random order. See, they become random 0, 3, 4, 2, 1. It was originally 0, 1, 2, 3, 4. After shuffling, it becomes 0, 3, 4, 2, 1. Some random order it becomes. If I do reverse or if I do sorting, let's say if I again do sorting, sort into Q. And one more thing I will do, reverse sort or sort. Reverse sort into Q. Let's print all of this one by one. What happens? See, sorting will give you in the incrementing order. Reverse sort will do in the reversing decrementing order. So this is the best thing about system Verilog. So what is the thing? It gives you what is Q. It tells you what is Q, how to declare a Q. And it gives you so many methods that you can use. Let's say I want to get the size of the Q. So what I have to do? Size equal to int Q dot size. Very simple. Then you display size equal to int Q size equal to %b size. Since I used a new variable called as size, declare int size. And one more thing is, do I need to always declare a Q of int only? No, you can declare Q of strings. You can declare a Q of integers, Q of bits, Q of bytes, whatever you want. I just took int only for my convenience, because if I start doing everything, you will get confused. So only for convenience, I took int. You could declare string, you could declare byte, you could declare bit, whatever you want to declare, you can do that. See, size is 5. Other than that, you want to insert one element in between. See, it's like Q, right? There are 5 people. You want to insert one person in between second and third index. So what you can do is int q dot insert at the third index insert 20 value. Then you display it. Insert at index equal to 3 int q. Now int q should have 6 elements. Int q should have how many elements? 6 elements. At third index you should get 20 value. Fourth is the 0th index, 3 is the first index, 2 is the second index. At 3 you are inserting 20. Let's say I want to delete specific index. Int q delete second index. Delete at index 2 and you print it again. See, you have deleted index 2, which is 2. So now new one became like this. So what is that you have to do when you learn system Verilog is you need to learn what all features are there, like q is there. Then you need to know what all methods are there and how to use those methods. So learning system Verilog is about knowing the language constraints and knowing the methods associated with that. Methods means these things: push back, push front, associated with it. This constraint and how to use those methods. This is what I mean by how to use those methods. So you need to practice this. Our course for initial 6 weeks, I told you, right? Initial 6 weeks will be focused on system Verilog language. Our idea will be the same thing, to make sure that we take a construct, we write all the detailed examples and learn how to use that. Later part of the course, 7 weeks, will be focused on practical use cases. Why do we use Q? Where do we use Q? Where do we use mailbox? Where do we use semaphore? Where do we use associative array? Those things we'll be doing in the later part of the course. Let's just do one quick thing related to int Q and then take a break. So what I will do is I'll declare one more array int
I have a question.
Yeah.
Actually, you are inserting only one value. If I'm having set of values, I have to insert or delete. How to do it?
You have to do it in a for loop. You have to write a for loop, and how many ever you need to insert, those many index for loop you do, and insert those values one by one.
Okay.
So in dynamic array, basically allocate 5 elements into int dynamic array and compare with q values. Okay. So how do I do that? Again, you write a for loop. So first you have to allocate memory to dynamic array equal to new of 5. See, this is not required for q. Okay. Whereas in dynamic array, if you don't do this, it won't work. It will give you error. In dynamic array, if you don't do new, it will fail, because it says that dynamic array doesn't have memory and you are still using that memory. Okay. Now, how to assign 10 values to it? Sorry, 5 random values to it. Int dynamic array equal to int dynamic array of I equal to $u random range 0 to 5. Something like this. 0 to 4 or 0 to 4, right? I'm just giving some random value between 0 to 4, and now I want to compare q values to dynamic array values. as I told you before, do not use int q equal to int dA. This is wrong. We should not do this, because we should never compare whole array to whole array. You should never do that. What you should rather do is, you should do something like this for loop. You should write if, you should write assert int dA of I equal to int q of I. Do this. So it is possible to access the q elements and index spaces also. That means what? It is possible to q elements can also be accessed on index spaces also. See, here we are accessing q of I. Of course, this will fail because randomly we assign, right? So the chance of their matching will be very less. Yeah, so they're failing at line number 53. At line number 53, if you see, they're mismatching. So Q is one of the very powerful constructs in system verilog. Q is a very powerful construct in system verilog. Why it is powerful is it comes with so many methods. This many methods it comes with, which makes it so flexible to work with Q, which makes it flexible to work with Q. Hence, Q is very useful, and most of the time you will see I will be using Q as well during our course work. So that is about Q. Mailbox, packed array, unpacked array. Will discuss the data types. Types declare to. Let us take a 10 minutes break. Once we meet after the break, we'll continue with the remaining aspects of the arrays and queues.
Hello, sir. I have a doubt.
This conference will now be recorded.
Okay. So let us start again. So one of the questions during the break was, is it possible to copy array elements to queue directly? It should not be possible. Let's try once. What we'll do? Int dA equal to int q. I mean, it may work because we are just copying the handle to handle, but ideally it should not be done. So you do it and you do the compare. So 53. So it is probably working. Let's see. Yeah, so it is working. So I would like to correct whatever I answered. So it is possible to copy q elements to dynamic array by assigning q to dynamic. Then you are doing the comparison. Because in line number 59, you didn't get any error message. That means that this match is happening. These are matching. Then let's go back to this. Okay, I hope you understood what is fixed size array, what is dynamic size array, what is Q. Mailbox I will cover later. Otherwise, just let me introduce you to what is basic mailbox. I mean, at least basic idea of mailbox. Mailbox is generally used in system Verilog for connecting various test bench components, like to connect generator to BFM. If you go back to my presentation, in this diagram, we use mailbox everywhere here. Wherever you see M here, mailbox, 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 probably a mailbox, yeah. So everywhere, wherever I have circled in red, all those places we use mailbox. That means what? Any component to component connection between in the test bench is done using mailboxes. What is mailbox is? Mailbox gives you first in, first out kind of behavior. Mailbox provides FIFO kind of behavior. Mean whatever you put first in, first out. The first transaction you put into mailbox, the same first transaction BFM will retrieve, so on. Same thing from monitor to coverage, same thing from monitor to reference model, same thing from reference model to checker. So whatever you give first, the same thing other component will get it. When you want such behavior, you need to go for mailbox. Now, what is the benefit of mailbox? In system Verilog, in Verilog, if you remember, we had to manually implement synchronous FIFO and asynchronous FIFO. Everything from scratch. In system Verilog, we don't need to do it. We don't need to do that. We just need to know how to instantiate. We just need to know how to declare a mailbox and how to use it. That's all. Let us try that once. SV labs mailbox.sv. Erase all runs. Module talk in module. Since I want to use mailbox, I just have to write mailbox. Mbox means the name of data type is mailbox. Instance name is Mbox. You can write, you may say, can I write XYZ? Yes, you can write XYZ. If you say, can I write XYZ? Yes, you can write XYZ. This mailbox, this is compulsory. This can be anything. I'll just for convenience, I'll use Mbox. Now what I will do is Mbox equal to new. First, I have to allocate memory to the mailbox. Mbox is a dynamic data type. Hence, we need to allocate memory to it before using it. Before we use it, we need to allocate the memory to it. Now, how to put elements into mailbox? Simple. You write a for loop. Int I equal to 0, I less than 10, I plus plus. Begin end. Mbox dot put some $u random range 10 to 30. You may be wondering what is that I'm doing this $u random. I'm just putting a number between a random number between 10 to 30. If you don't want it, you just put some number 10. What is the problem here? What is the problem with this line? All the elements in mailbox will be what will be the values of all elements in this mailbox if I do this? 10. I don't want that. What I'm doing is between this brackets and putting $u random range 10 to 30. I hope you understood what I'm doing. Do you have any questions here? Do you have any questions there? Next, what you do is, you have put some number. How to display the M box? Just let's do $display. Let's see whether it works. The pack printing. What is pack printing? M box equal to %P M box. To run this, what do you do? Just change it to mailbox. Do run that. See, it is printing 22, 17, 20, all these things. Max items is 0. Some other information it's printing, which is not relevant for me. But it is printing me what I want. Elements are 10 elements are there in the mailbox. That it printing. So it is possible to print using %P. That is the first thing. Second thing is how to get elements from mailbox. Can you tell me? To put values into mailbox, we use put method. So how do you get values from the mailbox? What should I use? What should I? Can you tell me? What should I use?
mbox dot get.
Dot get. So what I have to do? A equal to mbox dot get. That's all. You do this one. Now you do $display. What is error? Use task in an expression. Line number 14. Okay, get A. Next. This is what you need to learn. Whether to use, see, in case of Q, that was correct. In case of Q, it was correct. It will return the value. See, Q will return the value as a return value. Whereas in get, it comes as a argument. The value comes as argument. Whereas value comes as return value, There is a difference between them. So in case of Q, value comes as return value. In case of this, value comes as argument. So Q and mailbox getting value.
So we need to give new of n or any value.
So please come again.
Or do we need to give some value like size 10 or 20 like that in a new
No. New. This means if I write like this, it means it is capable of infinite size. If I do this, this means mailbox is capable of, inbox is capable of holding infinite number of elements.
size?
Whereas if I write new of 20 means mailbox is capable of holding up to 20 number of elements. Even in Q, there is such concept is there. When you declare Q of 2. int q of 2, int q of 3. If I write dollar, oh, sorry, q of 2, if I write dollar comma 25 means what? Can you tell me how many elements it can hold? So how many elements it can hold?
25.
26. Because lowest index starts with 0, maximum index is 25, so totally it can hold up to 26 elements. If you try to put beyond 26, it will give error. I mean, it won't accept it. Are you getting why the maximum element it can hold is 26 when I write 25 here? Are you getting? It is like writing int fixed array 0 to 9. What is the size of this array? Can you tell me?
10.
So that is about Q. Now mailbox. If I run this, it is getting 22 first, 17, 20, first in, first out. This is the first order. It is getting in the same order. Do you have any questions here?
Sir, I have a question. So
Yeah.
you have defined the packed array. Like that, we have a unpacked array. So where will we define that, and how to define that? Like percentage P, yeah, like how we define that unpacked array if it is there.
In fact, this is unpacked array only, right? Whatever we are doing, it's no percentage P. When I'm writing, what it is not referring to packed array. What it is telling is, I'll tell you. It is telling that when I'm writing the statement, what it is telling is print all the elements of M box in packed manner. Means what is packed manner is this is called as packed. This is called as packed. So if I write 10, 12, 18, 21, 20, 13. This is printing all 5 elements in packed manner. Instead of printing them separately 10, 12, 18, 20, 13 in 5 different lines, we can just print them in one line. That is called as packed manner. Is it clear to you?
Yes, sir.
Yeah. So this is about mailbox. Since you have asked about mailbox, since you have asked about packed and unpacked, let me introduce you to another concept called as packed and unpacked arrays. All these things we'll be discussing again in the later sessions. All I am trying to do is, before I go to the advanced topics of system Verilog, see, once I go into the advanced topics, you will find it more complex. If I start doing all this, what is it? Encapsulation, inheritance, polymorphism, we'll be using all these things. Packed array, declaring the dynamic array, declaring packed array. Lot of things we'll be doing. So you see here we're declaring a fixed size array. If you don't know what is fixed size array and how to work with fixed size array, then you won't be able to follow these examples properly. That is the reason I'm trying to make sure that you get the basics of data types properly. You understand what is queue, what is dynamic array, what is a fixed size array, what is mailbox, so that you will be able to follow the rest of the course easily. This is about mailbox. You understood, right? What is mailbox? Mailbox is simple, first in, first out kind of thing. Whatever order you are putting into the mailbox, in the same order you will get it. It's as simple as that. Next, we are done with mailbox. Next, we'll go to packed array and unpacked array. what is packed array and what is unpacked array. In very simple terms, vector in Verilog is called as packed array system. No difference. Absolutely no difference. Whatever you call vector in Verilog, same thing is called as packed array in system Verilog. So module top in module logic or whatever you want to do. Let's start with logic or reg, since you are familiar with reg in Verilog. 4.20 reg packed array. In Verilog I would have called it as reg vector. There is no difference. See, it is only for my convenience I'm giving this. Even if I name it as vec, there is no difference. Do you think there is any difference because of that? No, right? I'll write it as packed array because in system Verilog we will refer to this as packed array. I can declare one more packed array, minus 3 down to 1, packed array 1, packed array 2. What is that I want to do with that? Dimensions on left hand side. Yeah. For this packed array, what is the LHS index? Can someone tell me? For this packed array, first one, what is the left hand side index? Sorry? 0, right?
0, 1, 2, 2, 4. 0, 1, 2.
Right hand side index. I mean, what is the LSB? LSB index? MSB index. That would be rather correct. What is MSB index? Can someone tell me?
4.
For this one, what is the LSB index?
1. 1.
1. What is the MSB index?
-3.
-3. Concept is simple. Whatever is on the right hand side, whatever is there on the index value on the left hand side is MHP index. Index value on the right hand side is the LSB index. It doesn't matter. See, 1 is bigger. It doesn't make it MSB. So -3 is the MSB index. 1 is the LSB index because it is on the right hand side. If I do initial, begin, end, if I do reg PA1 equal to 5 tick B1011110. If I do reg PA2 equal to reg PA1, if I do this, if I do $display of reg PA2 of 0 equal to percentage B reg PA2 of 0. 1, 2, 3, 4. 1, 2, 3, 4. Can someone tell me what will be the value here? What will be printed here? Is it correct? Whatever I'm printing, is it correct? First of all, is it correct?
Oh, it's the array. So you're just printing the last index value. No, it's
Is it correct or wrong? Is it right or wrong what I'm printing?
wrong.
Why is it wrong?
Because we usually like print the vector value before, right? So this actually we printing the array value.
Negative index value.
We are printing non-existing indices. What are the indices of array 2? -3 to 1. But I'm trying to print 2 to 4. 2 to 4 doesn't exist here. Do you agree with that? Do you agree with that? 0, 1 will exist. Hence, this code is wrong. So what is that I have to print in that case? -3, -2, 0, 1, -3, -2, -1, 0, 1. You go here, you take -3, -2, -1, 0, 1. Is it clear to you? Now tell me what will be the value of -3. If I do this assignment, reg PA2 equal to reg PA1, what will be the index -3 of PA2? Can someone tell me? It will be 1. Tell me what will be the value of this one?
0.
It should be 0. So point is, it should copy index to index, position by position to position by position copy happens. By position copy happens. Starting from where? LSB onwards, least significant bit onwards. So this 0 will copy to the lowest location of PA2, which is lowest location is what? 1. So this will print, this will be 0. Next lowest location is what? 1. 1 will be copied to 0th index of reg PA2. Next 1 will be copied to -1 location. Next 0 will be copied to -2 location. Next 1 will be copied to -3 location. So if you do this, you should get 10110 print. So for this, what I have to do? Go here, make it packed array. See, 10110, 10. That is what we wrote, isn't it? 1010110. The same order it's printed. Okay. Next, packed array. One more example I'll give, because I want you to get all these basic concepts clear before we start with the actual system Verilog course. I will keep this to be bigger size, -5. Reg PA to be bigger size compared to PA1. Now what will happen? What will be the value of -5 and -4? It has got 2 more indexes, right? -5, -4. So it will be -4, -5. Tell me what will be the values of these 2 indexes? At least students who have attended Verilog must answer this, because we have already discussed all these details in all these things in very detail during vector assignments. What should be these values? Basically copying a smaller array to bigger. Copying smaller vector to bigger vector. What will happen? After copying the indices, remaining indices will be assigned with 0 values. So this should be what values? Tell me. 0, 0. So for this, you make it 1. See, I'm changing the file name here in the run.2. See, initial to are 0, 0. Similarly, if you do packed array 2, you take the same example. You just do the reverse actually. You make it PA2, PA1, PA2. So here to change this D6, copying bigger vector to smaller vector. MSB bits, most significant bits will be ignored beyond the size, beyond the copy limits. Copy limits. So I need to print 14 to 20. Yes, reg PA2, reg PA1. So see, this doesn't have -5, -4. Those we can ignore. In fact, 0, 1, 2, 3, 4 I have to copy. 2, 3, 4. 2, 3, 4. Reg PA2 I need to give -7 because, sorry, I have to give 7 because it is having -5 to 1 means it is actually 7 size. 1, 0. Now tell me what will be the values. Can someone tell me what will be these values? What will be reg PA of 0? Can someone tell me PA1 of 0? When I do this copy of PA1 equal to PA2, what will be the value of PA1 of 0?
0.
0.
It will be 0. What will be this value?
1.
1.
1. So this 1, okay, this got copied to that. What will be this one? 1. What will be the next one? 3 index. 0. What will be the next value?
1.
1. So what happens to these two? They get ignored basically. They are ignored because reg PA1 is only capable of taking 5 bits. So upper 2 bits are ignored, are not copied. Basically they are dropped, ignored from copying. So now if I run it, so for running this I have to change the file name to packed array of 2 in the vlog, and you run it, you will see what values 0, 1, 1, 0, 1. So 0, 1, 1, 0, 1. That is about how to work with packed arrays. Unpacked array is nothing but whatever fixed size arrays we discussed so far. See, unpacked arrays is nothing but fixed size arrays, everything we discussed so far. And other thing about packed arrays is it is not possible to write int 3 down to 0 in packed array. Illegal. Because we can't do packed array of integers. Only supported data types for packed arrays are reg, bit, logic. That's all. Or wire, whatever it is. These are the only single bit variables are supported. You cannot use anything multi-bit for packed arrays. Whereas this is supported. You know, right? Int unpacked array. This is supported. Because this is nothing but this is fixed size array, what we have discussed in the beginning of this session. UPA means what? unpacked array. What is the size of this array? Can someone tell me? What is the size of that array?
4.
4. Right. Next, unpacked array we have discussed. Dimension on the right hand side. Packed array means dimension on the left hand side. Data types: integer, int, byte, bit, and logic. So integer is signed variable, 4-state variable. It can take 0, 1, xz. I mean, it can hold the values 0, 1, xz, and it can hold plus and minus both. Int is signed, but it's 2-state variable. So it is used for quicker simulation performance. If you work with integer, it has to take care of x and z, so simulation can slow down. Whereas int will result in quicker simulation performance. Byte is signed 8-bit 2-state variable. I think let's not complicate it much. We'll discuss it later. Difference between byte and bit. Or let me just declare. Do it now itself. Byte bit difference. Module top in module. Byte A bit 7 down to 0 B. The question is now, are both A and B same? Because both of them are 8-bit variables. Both are 8-bit vector. Are both of them same? Are both A and B are same? Can someone tell me?
Yeah, size wise it's same.
Size wise they are same, but how they differ? They differ. They are different. B is signed variable. Signed variable means it can hold negative values. It can store negative values. Whereas A is unsigned variable. Even if we assign negative value, it will store it as positive value. So what does it mean? Let's understand it. Initial, begin, end. A equal to minus 20, B is equal to minus 20. So D will convert it, store it as negative and store it as positive value. How does it do? Minus 20 finally gets represented as 1, 0 something, right? That it will take as a complete positive value only. Even that sign, it won't hold. Whereas it will hold the sign. See, what you do is simple. Assert A equal to minus 20, B equal to minus 20. To run this example, just do byte bit dot st. Run this. Assertion error is coming on line number 11. What is line number 11? Here. Because B doesn't hold minus 20, it holds some other value. You know what it would have hold? It should be, I think, holding. It will hold it as 255 minus 20. It should be holding 235. Try 235. Let's try once. 235 or 236. What is it? Because when you convert minus 20 into binary format, if you consider the MSB position for sign, it will store it as 1 in the MSB position. Now it works. See, basically minus 20 is nothing but minus 20 is stored as what is it? You go to calculator. 236. 11 1 1 this one. So whereas when you say A, here also it is stored as same thing, but since A is signed, it will be treated as 1 1 1 1. This one will be treated as negative value. So MSB1 is treated for signed. Okay, here MSB1 that this one will be treated for magnitude, not the sign. That is because this can only hold positive values. How can I make it signed? How can I make it signed? Bit by 1, bit signed. Take the same example. To make it bit signed, what you do is just write. That's now it can hold. You have made it a. So to run this, what I have to do? Bit signed. That is okay. I have to declare in the this. First, I have to declare bit. Then I have to write signed. See, it is failing on line number 12. Which is line number 12? This is line number 12. So both will pass. Okay. So you can now this anyway we don't need. Okay. Reverse is also possible actually. You can make it unsigned. You can make a signed variable to unsigned, unsigned variable to signed. Everything is possible. Now if you see, this will give error. Line number 10 will give you error. Because till now byte was signed. You made it intentionally unsigned. See, line number 10 will give you error. So system Verilog has a provision called as signed and unsigned, where you can make signed variable into unsigned, unsigned variable into signed. Okay. That is about bit. Logic. Let's talk about one more variable called as logic. What is logic? System Verilog introduces a new bit variable data type called logic and bit. Two things it will introduce. Because in Verilog we had, it was reg and wire. You remember reg and wire. Why we need new data types? Why yes we need new data types? One primary reason is reg represents storage elements. Storage element in storage or registering element in design. Wire represent continuously driven point in design. In test bench, there are no such things. Test bench does not have any such things as about to. That is, there is no continuously driven points. There is no storage point. Hence, we needed two new data types called as logic, bit. Bit is two-state variable. Logic is four-state variable. What does it mean? Is it can store only 0, 1. It can store 0, 1, x and z. If I write bit a equal to x, so a will be stored as 0. A will be stored as 0 when I do this. Whereas when I write logic b equal to x, so b will be stored as x. So we will talk more about logic and bit as we go forward in the sessions. I mean, I'm just trying to give you a quick overview of basic data types in system Verilog. Next, arrays. We have talked about arrays based on when memory is allocated. Packed arrays, unpacked arrays. Memory is allocated into a single address location. Unpacked arrays. Memory is allocated into multiple address locations. Fixed size arrays. Arrays based on how memory is allocated. Fixed size arrays, dynamic arrays. In case of fixed size arrays, memory allocation is fixed at compile time. Int, integer, int, array 4 down to 0, 5 locations are allocated at compile time. This size cannot be changed. Once you have declared 4 down to 0, you cannot change it. Whereas when you go to dynamic array, you are not giving any size. So memory allocation happens at runtime. Memory is not allocated at compile time. It is allocated at runtime using int da equal to new of 5 or new of 10. 5 or 10 being the size to allocate. Okay, next. Understand the difference between integer and int. Can someone tell me what is the difference between integer and int?
Int is a two-state variable. It consists of 0 and 1, and integer is of 4. It consists of 0, 1, x, and z.
Yeah. So integer is 4-state variable. Int is 2-state variable. So when you display integer, it will give you x. Int will give you 0 because it cannot store x and z. Okay. Understand the difference between byte and bit. We just now discussed, right? Byte can store negative values. Bit can only store unsigned numbers, that is positive values. Understand the difference between logic and bit. Logic is 4-state 1 bit. Logic variables can store x and z. Bit is 2-state 1 bit. Bit variables can only store 0, 1. For all above, declare some variable of above data types and print their values, and assign some x and z based values and print those values. Just see, you assign each variable with x and z based values and see what values will be the output. Let's say for bit variable, if you assign x, it will still store it as 0 only. Any questions in this part of the topic? Do you have any questions in that? Is everyone okay to continue for some more time, or you need break now? We can continue for some more time, right? Without break?
Yes, sir.
Okay. Next, let's do one more example. I think we have already done this. We are just trying to make sure that we are not missing any of the questions. Dynamic arrays, queues, mailbox. Can you try all this from your side once? What I want you to do is just take these labs. Just do all this from your side. I mean, I have already done this. Declare integer a, b, assign a and b with random values between 10 and 20, display both a and b. Use $u random range, min max, compare a and b. Declare packed array of bit, array size of c, size of the 5 bits. Just I want you to try all these examples. Unpacked arrays, dynamic arrays, queues, mailboxes. In fact, whatever I have done, same questions are here, more or less. We have discussed summary, how to work with fixed size arrays, how to work with dynamic arrays, how to work with queues, and how to work with mailboxes. Next is now let us move back to system Verilog topics. The whole idea was to make sure that you get basic comfort with how to work with integers, how to work with fixed size arrays, how to work with dynamic arrays, queues, mailboxes, and what basic methods are there in these things. So now I'll go back to the presentation. So we have already talked about these topics. We already talked about this. Let us now understand what is functional verification. I mean, I'm now going back to the understand what is functional verification. We are going back to understand what is functional verification. Functional verification is what? Process of checking if design RTL code matches with the behavior as described in the design specification, is what we call as functional verification. Let us understand functional verification through an example. We'll take a simple example, what we call as traffic light controller. Okay. Why I'm taking this traffic light controller is it easy for us to correlate. You can easily correlate what is traffic light controller, all those things. What is the, how does the traffic light controller design works? It has an interface for configuring the traffic light controller. See, if you have traffic light, let's say this is the traffic light, someone need to configure, right, how the my red, yellow, green, they are going to behave. Someone need to program it. How much time they will be in red, how much time it will be in yellow, how much time it will be in green, when it will move. That is like interface. This is I'm calling as the interface for configuring the traffic light controller. It should have a reset signal for resetting the traffic light controller. Let's say sometime it goes wrong behavior. You know, right, sometimes you will see the traffic lights won't be behaving properly. To reset it to normal state, you need a reset signal. Reset. By clicking this reset, you bring it back to normal state. It needs to have registers for configuring amount of time it should be in red, yellow, green state. So how much time do you want it to be in red? Let's say 50, let's say 20, 30. These values user should be able to program. See, because if you go to the city, I mean, let's say in Bangalore city, let's say there are 1,000 traffic lights are there. Do you think all traffic lights come with same number, 50, 20, 30? Do you think all the traffic lights in Bangalore will come with same number, 50, 20, 30? No, right? Different traffic lights will have different time requirements. And having said that, I can't manufacture 1,000 types of traffic light controllers. I can't have 1,000 different styles of hardware. I will only have one hardware in which I'll program the registers. One register I'll program to 50. For some other traffic light, I'll configure it to 100. So red light should be 100 there. Somewhere else, let's say requirement is 130, I'll program it to 130, the same register. So my traffic light controller will behave with different time of red, different time of yellow, different time of green values. That is what I mean by registers for configuring amount of time. These are called as configuration registers. Next, traffic light controller requires registers to indicate current state of the design, called as status register. See, what is the current state? It is in yellow state, it is in green state, it is in red state. To indicate that, we need status registers. And user has an option to configure different modes of operation: blinking mode, manual control mode, high traffic mode. These are achieved by programming configuration registers. See, other than that, traffic light can work in different modes. See, you go in the night 12 o'clock, it won't be working like red, yellow, and green. It will be blinking yellow, blank, yellow, blank. Sometimes traffic police wants to control, like some VIP is going, he wants to manually control. Okay, this light will be red till the VIP passes away. That is manual control. Sometimes you need high traffic mode. See, during the weekdays there will be a lot of traffic, so you need the values to be higher. See, the same traffic light controller during weekends, I want timings to be like 10, 20, and 15. Same thing during busy hours, I want it to be like 50, 100, and something like 70. Because during the weekdays, I want to give more time for people to stop, more time for people to pass by, like that. During weekdays, I want to do this. One is I'm calling as high traffic mode, one is I'm calling as low traffic mode. So to set all these things, my design requires registers. my traffic light controller requires registers. To set all the design behavior, the traffic light controller will require registers. What are registers it requires? It requires a red time register. It requires a yellow time register. It requires a green time register. Other than that, it requires the mode register. Mode register means, is it going to work in blinking mode, high traffic mode, low traffic mode, manual control mode? For all these things, we need registers. See, without programming the registers, if I don't have this concept of register, then what I will have to do is I'll have to manufacture thousands of different types of traffic light controller. If design does not have option of configuration registers, these are called as configuration. Above registers are called as, above 4 registers are called as configuration registers. Can someone tell me what are all the configuration registers I'm referring here? What are all registers I'm calling as configuration registers?
Blinking mode, high traffic mode, low traffic mode.
So basically, no, that is not that. I'm referring red time register as a one register, yellow time register as one configuration register, green time register as one register, mode register as one register. So these are the 4 registers in the traffic light controller. User can configure the design behavior. User can configure the design behavior by programming different values into these registers. In this case, in the real life, user will be traffic police. Traffic police will program red light time to be 30 seconds, yellow light time to be 20 seconds, green light time to be 40 seconds. Now, he is not going to write a Verilog code. See, traffic police will not write Verilog code. Will not write Verilog code. He will have a simple way. There will be a simple provision. There will be a provision to configure this easily. There will be a provision for programming these registers. There will be like set red equal to 20, set yellow equal to something. Like that option will come, he will configure. If design does not have option of configuration registers, can someone tell me what will be the problem? What will be the issue? Can someone tell me what will be the issue?
Yeah, as we discussed earlier, we need to manufacture everything different, like for every
Yeah, we have to manufacture hundreds of different types of traffic light controllers. Because we need to let's say one of the junction requires red to be, let's say 10, yellow to be 20, green to be 30. Let's say it wants high traffic mode. Something like this. Manufacture one PLC. Another junction, second junction. So some other 20, 50, low traffic modes. Something like this. Manufacture different traffic light controller, which I don't want to do. Hence, what designer gives is designer gives concept of configuration registers. which we can program for our requirements, and design will work as per that. What is the benefit of this? What is the benefit of this by introducing configuration register? What is the benefit? We can use same hardware for different requirements. So hence, to program these configuration registers, I need a design interface. To program these configuration registers, I need an interface. That is what I'm telling. Interface for configuring the traffic light controller. So what is meant by configuring traffic light controller? Setting a specific value of red time, setting a specific value of yellow time, setting a specific value of green time, setting a specific value of mode register. Now going back to Verilog, most of you have come from Verilog, right? In Verilog, how it would have been done is we would have written an APB interface. We will use APB interface. We would have written at the rate of positive edge of clock or P clock, P address equal to red time reg. It's a parameter. PW data equal to, let's say, 20. 20 seconds we are configuring for red. 20 seconds for red. P write equal to 1. And P enable equal to 1. Then wait for P ready equal to 1. This is what we would do for red light configuration. 259 to 264 Y5. Now for yellow, you have configured a different value. Let's say 30 seconds for yellow. Similarly, green. Let's say green is 50 seconds. This is what we would have done actually. And this is what we have to do from outside. During the verification, to verify traffic light controller, I have to program the registers like this. Then my traffic light controller will start functioning with the 20 red time, 30 yellow time, 50 green time. Similarly, I can set blinking mode also. I have to use mode register. Then I have to give blink. Some value, again it's a parameter. Blink is a parameter, is a Verilog parameter. Parameter will have a value, right? As you know. This is what I am calling as configuring the traffic light. Now, typically, if you see traffic light controller, it will be nothing but a state machine and configuration and status registers. So, if I have to verify this traffic light controller, first, what do I start with? How do I start with verifying the traffic light controller? I will start with verifying TLC. Will start with reading the TLC specification, listing down the features, come up with scenarios, then developing the test plan, then develop test bench, develop test cases, run all the tests, and make sure all tests are passing and coverage is 100%. This is where your verification is complete. Same thing we have done. I haven't really done the verification of traffic light controller. We are just taking that example to understand what is meant by reading specification, what is meant by listing down features, what is meant by coming up with scenarios, what is meant by test plan, what is meant by test bench. We are just doing that. We are not going to develop the test cases. We are not going to run them because we have some other projects where we do this thing. We are just trying to understand what is verification. So first you read the DLC specification, list down various features it supports. What are the features it supports? Reset feature, normal operation, blinking mode operation, manual control, high traffic mode. Different features are there. How do you verify the TLC? How TLC is verified? Configure design TLC for different modes of operation. See, you change these values, configure it differently for different requirements. Once in blink mode, once in high traffic mode, once in low traffic mode, once in normal mode. Okay, like that, different features you configure. It is done by programming registers. Keep changing the configuration. Check if traffic light controller is following the expected behavior. So you randomly check. Let's say if I give you laptop and ask you to check whether it's working or not, what will you do? You start doing a lot of things, right? You will connect, you will do USB transfers, you will do keyboard checking, you will do display checking, you will play audio, you will play video, a lot of things you will do. Same thing you will do. You keep changing configuration in the design. Check if traffic light controller state, red, green, yellow, is following the expected behavior. Whatever you're expecting, is it behaving like that or not? So based on the time you have configured into registers. User has two options to verify the design. To verify this traffic light controller, there are two options. One is manually write down the expected pattern and compare with the actual. See what is what? To check this design, to check TLC behavior, one option is manually write down the patterns, the TLC output pattern. What is mean by that? At t equal to 0, it should be red, state should be red. At t equal to 30, state should be yellow. At t equal to 50, state should be green. At t equal to 100, state should be red again. So on. This is like manually writing down and open the waveform and see whether as per the waveform is it happening or not. This is very tedious job. I don't want to do it. See, this is prone to errors and tedious. I don't want to do this. That is where comes a concept called as use a reference model which will give you the expected pattern. And compare it with the actual pattern, actual state pattern given by the traffic light controller design. I will use a reference model. What is the other one? Create a reference model to predict the design state, that is expected values. Compare the design output to the expected output state. So what will you do in that case is you create one reference model. You have a design. Using the bus functional model, you program traffic light controller. You program the reference model also with the same values, both of them. Monitor will convert this interface signals to reference model input signal, input format. Okay. Now this will give me actual state. This will give me expected state. Through monitor, you collect it and you compare. Through the monitor, you collect it, you give it to checker, and you compare both of them. If all the things match, then design is working fine. If they don't match, design has some issue. Somewhere either you have done mistake in reference model or you have done a mistake in traffic light. So I hope you have understood till this point, creating reference model, why we need to create reference model. Next, let's go to next step. What is mean by TLC configuration registers? See, configuration register is how a processor or microcontroller controls the traffic light controller behavior. See, I want to tell that you should be in blinking mode, you should be in high traffic mode, you should be in red time for this much, yellow light for this much time, green time for this much time. Those can be configured into this red light time, yellow light time, green light time, mode register, everything can be configured. Traffic light controller needs status registers for the following. We need to know what is the current state of traffic light controller, right? Is it red state, yellow state, green state? To indicate that, we need status register. So totally traffic light controller will have 5 registers, 4 configuration registers, 1 status register. Do you understand what is 4 configuration registers and 1 status registers? Sorry, it is not state. Status. Do you have any questions till this point?
No, sir.
Okay. Now if I go forward, understanding the PLC design interface. See, in our just some time back, we took example of APB interface. Do you think without some interface like that, is it possible to configure the design registers? Without APB interface, would it be possible to configure the traffic light controller? Something like APB unit, if it need not be APB, it can be any interface which has got some signals like address, write data, write read signal, enable, ready signal. We need some such signals. So hence we need PLC design interface. Do you understand why design requires an interface for programming the registers? Everyone? That interface should have signals like reset, clock, address, data, valid, and ready signals. Now, how TLC is verified? Connect a bus functional model to the design interface. In real world, in real traffic light controller, it is connected to a microcontroller doing the role of BFM. See, in real life, microcontroller is the one which is going to program the traffic light controller. See, in real life, this is the traffic light controller. These are the states, let's say red, yellow, green. These are the lights. Here, there will be one microcontroller. This interface is APB interface. In real life, this microcontroller is going to program MUSI microcontroller. I mean, this is going to program the registers in this. Accordingly, my lights is going to switch from red to yellow, yellow to green, and they keep configuring. They keep switching. But in verification purpose, I'm not going to use microcontroller. In place of that, I'm going to use something called as bus functional model. I'm going to use something called as bus functional model, which is going to mimic as if microcontroller is there. Understand again, in real life, traffic light controller is connected with microcontroller or some mini processor, some small processor. So in that hardware, microcontroller is going to program the behavior of the traffic light controller. When we say it is going to configure, what does it mean? It will be programming the registers which are inside the traffic light controller. How many registers are there? Mode register, red time register, yellow time register, green time register. By configuring those registers, microcontroller will configure the traffic light controller behavior. But when it comes to our verification, we don't have microcontroller. We need to mimic this interface as if microcontroller is there. That mimicking component is called as bus functional model. The bus functional model will behave as if it is a microcontroller. What does microcontroller BFM will do? It will generate transactions to configure the registers for as per test case requirement. Say as per the different test case requirement, BFM will generate transactions for configuring the registers. So when I draw the complete architecture diagram, it is going to look like this. Please take a look at this diagram and let me know if you have any questions here. Do you have any questions in this diagram? Do you understand how it works? As per different test case requirements, test case 1, let's say test case 1, BFM will configure one set of values. Same values will be configured here. One pattern of output will come. We'll check it. Test case 2, new configuration. BFM will do the new set of configuration. New configuration here. Again, it checks. Test case 3, one configuration, new configuration. So overall, as we run various test cases, design will be checked for different modes, different timings. Hence, we verify the DUT. This is what we mean by thorough verification. I told you, right? Module level verification is done, thorough verification in IP verification. You program all possible values into the design registers. What is the need for reference model? Reference model is replica of traffic light controller design. It is just that it is implemented using system Verilog. See, DUT is implemented using Verilog. Reference model is implemented using any other language. It doesn't matter, because my whole goal is only to synthesize this traffic light controller. I don't worry about reference model, because I only want to make this as a hardware. I don't need to make BFM hardware. I don't need to make monitor hardware. I don't need to make reference model hardware. So I can take any flexibility to develop BFM, monitor, reference model, monitor, checker in any language. I can develop them in system Verilog. I can develop them in UVM. I can develop them in system C, whatever. Let's say tomorrow my QuestaSim supports Java. I can develop this in Java also, because I don't need to convert this into gates. Hence, I can do whatever language I want to implement these components. But DUT must be synthesizable, must be converted to gates. Hence, I have to do it in Verilog or VHDL only. Synthesizable constructs only I have to use for this. So now, what is the need for reference model? Reference model is the replica of traffic light controller design implemented using system Verilog. Without reference model, user has to manually come up with the expected state of traffic light state for each second of operation that I'm going to compare. I have to manually write down 21 seconds red, 22 seconds red, 23rd second green, which by using reference model I don't have to do. Reference model will do that work for me. In summary, I will tell you what is this whole thing is coming down. Reference model is the verification engineer understanding of the spec. DUT is the design engineer understanding of the spec, of the design specification. I mean, if you don't understand what is spec, specification, design specification. We are just trying to compare both of them. We are comparing both these people's understanding against each other. How are we comparing? We are comparing by giving different inputs, same inputs to both the components, and comparing the outputs. Okay, if outputs mismatch, one of their understanding is wrong, then we debug whose understanding is wrong. It is possible that verification engineer has understood things wrongly and he has done a wrong coding in the reference model. But in any case, we'll come to know. If output mismatches, we'll come to know. If output matches, there is a good chance that both understanding is correct. Like this, we run various test cases. Like all possible scenarios as test cases. Then we come to know as test cases. Then we come to know whether design and reference model are matching in behavior. Now, do you understand what is the role of BFM? BFM plays the role of a processor, generate transactions as if processor is doing. What is the role of monitor? Monitor interface level signals, whatever is happening here, give those collected values to the reference model. Give those as input to reference model. What is the role of checker? Compare expected pattern to the actual pattern. This gives you actual pattern, this gives you expected pattern. Compare both of them. Traffic light controller design verification, how it is going to happen. Writing test cases. Writing test cases is nothing but, see, I told you, right, different test cases. Test case is nothing but programming registers differently, registers with different values, and generating different types of inputs, different type of input values. These are called as test cases. So what is test cases? Generating different configurations for traffic light controller register programming, which in turn would change the FSM behavior, generating required pattern of red, yellow, green in traffic light. And basically do different configurations to the traffic light. How design verification works? How do we do design verification here? At each time unit, compare the expected state with the actual state of the design. At each time unit, compare the expected state with the actual state. That will tell whether design is working properly or not. Now, in this whole process, how system Verilog helps with functional verification? System Verilog has a lot of constructs to make test bench and test case development easier. Verilog has very few constructs. I told you in yesterday's session or demo session, it has got module, always, initial, task, function, few procedural blocks, and few operators. That's all in Verilog. Whereas System Verilog has lot more things, lot of constructs. Like what is System Verilog additionally has? Additional constructs in System Verilog. Object-oriented programming constructs, interface, mod port, clocking block, constraints and randomization, which was not there in coverage. What else? Different types of arrays, different types of data types, more operators, lot more operators. Other than that, it has got concept of DPI. Other than that, it has got concept of I think rest of them common with that. Other than that, it has got concept of assertions. So all these things makes it easy to develop the test bench and test case development. Because you have more features, you can develop the test bench more easily. It makes it easy to generate stimulus, generate test cases, implement the reference model, implement the checker model, track the project completion status. I mean, everything becomes easy because you have more options to work with. Since System Verilog has more constructs, it provides more options for you to do the same thing. Hence, the programming becomes easier. Till this point, do you have any questions? In summary, what is functional verification? Functional verification is checking the design behavior with respect to the design specification. See, design specification is different from user manual and spec. When you purchase a mobile phone, you get a user manual. It is not same as that. I mean, that user manual is not design specification. Please understand, whatever user manual you get when you purchase mobile phone, that is not design specification. Design specification is a different document. It will be almost thousands of pages. It is going to talk each and every aspect of the mobile SoC. What is the functional verification flow? In summary, read the spec, list down features, break the design features into scenarios. Test cases can be developed targeting specific aspect of the design. It also helps with code reuse, enables multiple engineer work on the specific scenarios. See, if you divide the design into multiple scenarios, what is the benefit is, if you have a design, you develop one test case which checks all features. All features are checked in same test case. If test case fails, tell me what is the problem with this? Let's say we develop all test cases, all features in same test case. During a design verification, let's say we develop all features verification in same test case. What is the issue with this? Can someone tell me? Can someone tell me what will be the issue? Sorry, you don't know. I mean, if it fails, if the test fails, we don't know what is causing it to fail. We don't know what feature or scenario causing it to fail. Whereas implementing different feature verification, feature or scenario in different test cases, when a test fails, we know what feature is not working, what feature specifically is not working. Hence, we can easily debug it. Do you understand why we are dividing the whole thing into different scenarios and developing them as different test cases? And it will also enable multiple people to work. See, if I only do one test case, only one person has to work, right? You cannot have multiple people develop same test case. Whereas if I have 10 test cases, I can ask 5 people to work two test cases each. Hence, it will help complete the work quickly. Without splitting design features in multiple scenarios, it is difficult to narrow down cause of design failure. Why? If it fails, we don't know why it failed, what scenario didn't work. Then targeting each scenario, like multiple scenarios, right? You're targeting each scenario, write a test case target to target each scenario. Let's say you have 10 scenarios. You write 10 test cases targeting each scenario. Finally, use all test case passing. All test cases should pass. I should get 100% functional coverage, code coverage as functional verification closing criteria. Once this happens, I know that functional verification is working. Functional verification is completed. See, somewhere functional verification has to complete, right? So that what is the point where you say that functional verification is complete? When do we say that functional verification is complete? When do we say functional verification is complete? All test cases should pass. 100% functional coverage we should get. 100% code coverage we should get. 100% assertion coverage we should get. Now, all these terms are new to you. You don't know what is function coverage. You don't know what is code coverage. You don't know what is assertion coverage. That is why we have 13 weeks course. Okay, if I try to teach everything in one session, it won't be possible. You won't be able to grasp it. We will understand all these things as we go forward with the different sessions. Next. I hope you understood till this point. Do you have any questions till this point? Next. Why don't we code complete test bench in single class or single file? Can someone answer this? Why don't we do this?
If some error happens, we don't know what is causing the error. So it is easy to read.
Yeah. No, that is not that. That is different. I was talking about different test cases. Here I'm talking about why don't we code complete test bench in a single class or single file. Generally, test benches are developed for modularity and reusability. What is meant by modularity is the concept of dividing test bench into various components based on functions they need to support. Simple analogy is test benches are always developed with modularity in mind. Test benches are always developed to be modular and reusable. See, modularity is what makes reusability possible. So in summary, we try to make the test benches modular. If you say modular, you are automatically telling that it is reusable. Now question comes, what is modularity? Example, I'll give you one simple analogy. A house consists of many rooms, right? House is not a one big room, right? Now, can you answer that question to yourself? Why is my house? You imagine your house, right? Why do you have different rooms? Kitchen room, bedroom, bathroom, hall, a passage area, different rooms, utility room, utility area, balcony, different rooms. Why do you have different rooms? Why don't you have all rooms in as a one big room? Whatever answer you get, your answer will be you want house to be modular. What is modular is based on what you want that room to do. Let's say you want to eat, that will become dining room. You don't want that dining room to be mixed into somewhere else. This whatever answer you get, see, you may get two, three ideas. This is why we are dividing the house into different rooms. Same is the reason why we are dividing the test bench into BFM separately, monitor separately, reference model separately, monitor separately, checker monitor separately. We don't want to code all the things as one big module, I don't want to code it as one big module. I want BFM to be separate, monitor to be separate, reference model to be separate. Now again, you question the same thing, why my house is having 7-8 different rooms or 4-5 different rooms. Same is the answer why we want test bench to be modular. What we want to do is whatever updates you do in BFM, I don't want them to be impacting monitor. I want monitor and BFM to be independent. They don't want to be dependent. Whatever updates I do in monitor, they should not impact reference model. Whatever updates I do in reference model, checker should not be impacted. This is one benefit. This is one thing I want to do. The second benefit is if I code them separately, engineer 1 can do this, engineer 2 can do this, engineer 3 can do this, engineer 4 can do this, engineer 5 can do this. Okay, now one person working on a task will complete the same work in 5 days. 5 people working on the same task will finish the same work in 1 day. Hence, this concept will allow us to complete the test bench development quickly. So test bench development will get over quickly. I can quickly move to the developing test cases and debugging those test cases. Hence, we go for modular approach. That is one benefit. The second benefit is the modularity results in reusability. What is meant by reusability is somewhere else I have a new design. Let's say I have a new design where I have the same interface. Let's say it is the APB interface. I have a APB interface here also. Let's say this is some other design. Let's say it is interrupt controller. Okay, I can use same BFM, I can use same monitor. No difference at all. Only the scenario I need to change. Only the inputs I'm going to give need to change. The exact same component I can use, exactly same monitor I can use. If I code everything single, I can't reuse it because reference model is mismatching. Checker is different. Hence, I cannot reuse it. If I code it separately, I can reuse only what I want. I can reuse only BFM. I can reuse only monitor. Rest all things I will develop myself. So what do you think is better? Coding every component, all the components in single block is better, or coding them in separate blocks is better? Can someone answer that?
Yeah, coding different is easy.
Yeah. Dividing test bench functionality into different components ensures reusability of these components across different test benches. I will be able to use same components in different test benches. If I code them in a single block, reusability is not possible because that same code has some other functionality which is not applicable to different test benches. Whereas by maintaining them as different blocks, I can only use the block which is required there. Is it clear to you? Okay. Now, if I have to use Verilog for test bench development, what is the problem? Verilog is not meant for modularity and reusability. Verilog is not good for modular and reusable test benches. Why Verilog is not good for test bench development? It was purely developed to be a RTL coding language only. See, Verilog, if you someone categorize Verilog, someone calls it as what? Verilog is called as hardware description language. And when someone wants to call system Verilog, what they call it as? They call it as hardware verification language. Means, see, Verilog was always developed, Verilog was invented to be always used for developing the designs only, design code only. It was not for verification purpose. Whereas system Verilog is purely developed for, system Verilog is invented for verification purpose. Actually, it has everything of Verilog. So system Verilog has everything of Verilog. So that means it is also suitable for design purpose also, design code development also. Hence, you can call, system Verilog can be called as HDBL, hardware description and verification language. It can be used for hardware description. It can also be used for hardware verification. Why it is not good? Why Verilog is not good? It doesn't have many features. Mostly has features which are meant for RTL coding only. So it has got features like, what is that Verilog has? Verilog has always, module, always, initial, task, function, for, while, repeat, case X, case Z, if, else, assign, different gates, logic gates are there, generate is there. That's all. These many only are there, right? These are mostly above, most of the above are meant for design purpose. Whatever is left, like few things, like what is meant for verification purpose? Meant for verification purpose. Initial is meant for verification purpose. Repeat is meant for verification forever. Some of them, these are very few constructs. These are very few constructs. Hence, test bench development becomes difficult with Verilog. With Verilog. Whereas if you go to system Verilog, I will show you. System Verilog has, I don't know where it will be. Here, so many constructs. See, imagine, see Verilog has only fewer constructs. System Verilog has many constructs, which makes test bench development easier using system Verilog. Okay. Now, how system Verilog helps? System Verilog adds more constructs. It is based on object-oriented programming. It has got data types and operators. Arrays. We have seen different types of arrays, right? I think you could have got a feel of how system Verilog improves on top of Verilog. Lot of things we did today are not applicable to Verilog, like dynamic arrays, queues, mailboxes. All of them don't apply to Verilog. It has got constructs for inter-process synchronization, functional coverage, interface, program, clocking block, mod port, fork join, different combinations are there. Constraints and randomization, assertions, DPI, and different scheduling regions. There are many things which make system Verilog more efficient in developing the test benches. Now, how UVM helps? UVM is developed on top of system Verilog. It is a pre-implemented base classes, very well defined guidelines on how to do everything in test bench. I mean, in system Verilog, verification engineer has to define all this behavior from scratch. Whereas in UVM provides predefined guidelines for all the above. In system Verilog, even though it comes with construct, you have to do everything from scratch. Whereas in UVM, there are pre-implemented base classes are there. You just have to use that base implementation and only do the required additional implementation. So it makes it easy to come up with test bench architecture, test case coding, test bench component coding, test bench connections, reporting messages, test debugging. Everything becomes easy with UVM. In summary, if I use Verilog for verification purpose, if total verification timeline is for 6 months, I will take 3 months for setting up test bench. 3 months for verification purpose. Verification in sense, developing test cases, running those test cases, and debugging those. I will take 3 months because totally 3 plus 3. Using system Verilog, this will become 2 months, this will become 4 months. I mean, the verification efficiency goes up. Verification time goes up. Hence, quality of verification improves. Same thing using UVM, it will take only 1.5 months for setting up test bench. So remaining 4.5 months will go into verification. Again, the verification type goes up even more. Quality of verification improves further compared to Verilog or system Verilog. Are you getting why we are what? So are you getting what is the motivation? Why industry is moving to UVM based verification methodology, UVM based verification? UVM comes with base classes, base class implementations, and a lot of guidelines, which makes it easy to develop the test bench quickly and efficiently. That is important. Efficiently, which effectively reduces the time taken to develop test bench, which effectively reduces the time taken to develop the test bench. That's why industry is moving towards UVM for test bench development. That is why if you are any of your looking for functional verification career as a job role, you want to try, you need to learn UVM also. I will just spend another 10 minutes and we'll conclude the session. Okay, now let us talk about difference between SOC verification and module level verification. See, SOC design and verification. Design and verification mostly works on IP reuse in SOC. You use verification IPs and design IPs. System Verilog is not used for test case writing in SOC verification. Test case is developed using C language. It is compiled to generate equivalent assembly code. All the C language constructs are not used. Mostly C test case involves register writing, register reading, memory writing, and memory reading. Test cases are mostly directed to specific scenario. Test cases are mostly directed for specific scenarios. System Verilog is used only for peripheral BFM model coding, integration of DUT, BFM models in the topmost module using interfaces. System Verilog is majorly used in module level, subsystem level verification. So where do we use System Verilog in that case? We use it in module level verification and subsystem level verification. Majority of work in SOC verification goes into debugging C test cases. Whatever test case we have developed, majority of work, majority of time in SOC verification goes in debugging those test cases. Most of these are ported from previous versions of the project. Verification of each feature is essential for signing off SOC. Hence, verification plays major role in SOC. What is the expertise required in SOC design verification? You need to have good understanding of SOC architecture, processor understanding, standard on-chip protocols, and you need to have debug expertise. This is about SOC design verification. So I will talk more about this in the next session as well. This is what we mean by SOC. One example of SOC architecture. Okay. Whatever, let's say you are developing a test case targeting keyboard, ARM processor need to generate the transactions. That needs to get the assembly code as the instructions. This is first developed in C language. There is a ARM compiler which will convert C language into assembly code. ARM processor will fetch that instructions and do the transactions with keyboard. That is why you need C language. Without C, you have to write everything in assembly code. Whereas with C, you develop at a higher level, for loop, if, like that. That can be converted into assembly code and the ARM processor will run those instructions. Okay. What is module level design and verification? In module level design verification, design is exhaustively verified for all possible design configurations. You remember traffic light controller example, where we have configured traffic light controller for different modes: blinking mode, high traffic mode, low traffic mode, manual control mode, different modes. So in that type of verification is called as module level verification. Design is exhaustively verified for all possible design configurations. Various design configurations are achieved by programming the configuration registers. By programming different registers with different values, you get different design configurations. And verification closure is achieved using following criteria: 100% test case passing, 100% functional coverage, 100% toggle coverage. Test cases consist of following. What is the test case will consist of? Constrained random verification based test cases. You first generate random test cases. Once you are not able to reach some corner points, then you develop directed test cases. C language can't be used for developing test cases for module verification. I mean, in module level verification, we don't use C language. Why we don't use? In module level verification, there is no processor. Processor is not there. If I am verifying keyboard controller, only keyboard controller is there. All the other components around the keyboard controller are replaced with test bench component. I told you, right, in traffic light controller, we are replacing processor with BFM. Same is the concept here. We are replacing all the components around the design with test bench components. These test bench components are going to simulate the behavior of the processor plus interconnects. These test bench components are going to simulate the behavior of processor plus interconnects. If we have to do above using processor, it is quite difficult to achieve random behavior. Same, if done using SV, BFM and generator, user has a lot of flexibility to generate random scenarios. So let me explain all this in tomorrow's session, I think in the next session, because probably you didn't follow much in this because we have done quite a lot of content in this session. So let me restart with SOC design and verification in the next session. So we will stop the session here. Do you have any questions before we end the session?
Sir, when will be the labs for US people?
We will first list down how many students are from US, how many are from India, how many are weekend students. Then I will let you know the exact schedule.
So today will lab happen or not?
Today lab won't be there because today is the first session, right? So what you can do is you make a note of this link. This link I'm posting it in the chat window. Just practice this once. See, again, what I want to tell is, do not wait for someone to come and tell that do this. Do not wait for lab session to happen tomorrow or day after tomorrow. You can start today itself. Whenever you get time, you can start opening it and start doing it. To get a job, you need that motivation. If you think that someone is going to come and someone is going to ask me to do, someone is going to help me do something, you are not for the job. I mean, trust me, there is so much competition. If you work with that kind of motivation, it won't work. You have to have motivation of I should do. If I need support, I will take help from mentor or trainer. That approach you please develop. Okay, I won't be repeating this sentence every day. Okay, but you remember yourself that what is that I am doing from my side? Am I doing all the assignments? Am I trying all the possibilities? Okay, then if I'm not able to proceed, then I will go to trainer for the support. Of course, lab sessions are there to support you. You do the things, but it is good for you to practice so that you can get the maximum benefit of those lab sessions. So all the course material, all the schedule, everything will be publishing by end of the day. So please follow those details. We'll end the session here.